Hello. Welcome. We are going to kick off Berlin DePIN Day right now. Welcome, everybody. My name is Tom Trowbridge. I'm a co-founder of Fluence Labs. Just so you guys, I'll be talking about Fluence a little bit later, but Fluence is a decentralized serverless compute platform. We're deeply in the DePIN space and are excited to host these events to bring the DePIN community together. I want to first thank our other sponsors, our seed investors, 1KX. Thank you very much for hosting this event with us. And also, obviously, both Impossible Cloud and DRPC for being our other sponsors. So let's give a hand to all the sponsors that made this possible, please. Thank you. We kicked off our DePIN series in Denver on February 27th. And we had about 500 people in Denver. We had about 25 speakers, and it was a terrifically attended event. And that made us realize there is a lot of demand for the DePIN-focused events and DePIN-focused content. And so that has inspired us to do this event here, and there's a number of events coming. In fact, since Denver, I launched a DePIN podcast called DePINed. And we've had a whole number of great guests, some of whom are speaking today, and a long list of guests that have recorded and haven't yet been launched. So if you're interested in this space, you want to learn more about it, you definitely should check out the podcast. That's my shameless plug for my podcast. But the DePIN space is continuing to grow, and I think first it makes sense to start with a definition. So, and because there's a lot, whenever a space gets hot, everyone wants to jump into it and become a part of it. And so I start a lot of the podcast by asking the host to define DePIN, just so we're on the same page. And the kind of common definition that I've arrived at is crowdsourced physical infrastructure bound together by a common software layer that is secured and incented by crypto economics. And so that is a pretty encompassing definition, and I think I try hard to make sure that the projects that we have speaking are inside of that definition. And then you can get to a variety of other providers who either are layer ones that they think are suited for DePINs. There are other use cases for DePIN. There's a number of other kind of ecosystem that can be on top of that. But I think we should be very clear on what a true DePIN project is and stick true to that definition, because if we don't, it will expand and become almost meaningless, as has happened to other kind of subsectors as well. So that's I think that's one very important kind of thing we should all keep in mind. But we are also worth recognizing the interest that's growing. And I have a list here. The reports published recently, Binance has published a report on DePIN, Messari, Blockworks, Crypto.com. So this sector is still early days, but is getting much more research and exchange attention. And I think that you're going to see that from the panelists and speakers today, the terrific resources that are being put into the space, which I think is only going to continue. So, regarding the other upcoming events we have a really terrific event in Austin on the 31st. Next week, that's where some of us will be around Consensus. So next Friday in Austin, we're doing another DePIN Day. And then in Brussels on July 10th, we're doing one as well, which we're very excited about. It's going to have a terrific group of attendees, very different from this group as well. We'll also be hosting one at Token 2049 in Singapore in September. Also, on June 7th, in Belgrade, Web3 Mine is going to be hosting a DePIN Day. So if you're in any of those locations, certainly attend those, you will, our objective is if you attended every single DePIN day, you would see very different speakers and learn something new at each one. So these are supposed to be DePIN focused, but this sector is so big, there's so many different projects doing different things that there's actually a ton of content that we can keep generating, and every location brings different projects which have different perspectives. So I think that's why we're excited to do it in all these locations. And so if you're interested, please attend those. And if you'd like to sponsor or you'd like to speak, let us know or apply on the website. We'd love to have more sponsors, love to have more speakers, love to expand our list of participants. So thank you very much for attending, and I think I will hand it over to Vuk to talk about staking, DePIN staking. So with that, I will give a round of applause to Vuk from Web3 Mine.
Hey everyone, today I'm going to talk about risk taking in the context of DePIN. But before I do that, I just want to remind everyone what risk taking is in the context of Ethereum, and maybe zoom in a bit better just to kind of align on what risk taking is in the first place. So if you look at risk taking in the context of Ethereum, it's basically allowing protocols to build on the same resource, which is the security that Ethereum allows protocols to build on. So you would think of these EVSs as basically networks that are building on top of Ethereum, but they are sharing the same resource, which is the stake that validators actually have, and they are basically bringing more value to the end user by actually doing two activities at the same time. If you look at the stakers, basically what they're getting multiple rewards because they would get the reward of Ethereum, and they would also get the additional reward by restaking into a separate protocol. Well, if you look at what the networks get, they're basically not paying for the security of the network by themselves. Imagine having to bootstrap a network of stakers. You would need to have, first a bunch of miners that actually do it, and they need to be incentivized. Then you need to have a bunch of liquidity that needs to be locked on these miners. There is a bunch of coordination that goes into this. All of this is cost that each of the network needs to cover themselves. And usually what they do is they do that by providing some inflation through the block rewards. And ultimately, this is sell pressure on their economy. Now, if you look at the DePIN, it basically has very similar problems because you do not need to get the security from the core network, but you need to get the resource. So you need to execute the job somehow. It's either a storage job, like in the context of Filecoin, or it is a compute job in the context of Fluence. But these jobs need to be executed on the validator, and this matching needs to happen somehow. Now, for the stakers, what they care about at the same time is basically the same as Ethereum, which is maximizing the utility of their liquidity by increasing the yield. So at the end of the day, the token holders want to be greedy and earn as much as possible from their liquidity. While for the protocols, they have the same exact problem as what protocols have in the context of Ethereum, which is we want to reduce the cost that it actually takes us to run our infrastructure. Now we are not dealing with security, so we do not need something like eigenlayer, but we do need this layer of resources on top of which we can actually run the jobs of our DePIN networks. So how this specifically looks like in the context of Ethereum is that you have Ethereum stakers and validators that basically are combining together resources to provide a utility to the networks that are building on top of the risk-taking protocols. And at the end of the day, what happens is that these networks have the same utility, but at a much lower cost because they're sharing the cost with the Ethereum, and most of these validators are already running Ethereum. While for the EVS, it's basically allowing them to like tap into a resource pool that is already there, which is consensus security from Ethereum. And they're also able to provide additional yields to the validators running their stack. If you look at what we do in the context of DePIN, it's basically the same. It's just a different context because the paradigm is very different. Now you're not doing like transactions on Ethereum, where this is the main utility that you provide, but rather you're doing a job that requires a resource. This job like needs to be either some kind of compute or it needs to be storage, but ultimately this job requires this resource, and this resource needs to be provided by a hardware provider. Now, the difference is that in this particular context, instead of reusing the liquidity twice, because the security is the main paradigm here, you need to use the hardware in ways that it's more efficient in order to be able to share the cost between the different DePIN networks. So you're not able to use the same GPU for two workloads at the same time, because that's infeasible. But what you're able to do is you're using the same providers by using the resources on these providers on multiple DePIN networks, which also allows you to do like cool things like interop between the networks and other things that I might cover in the Q&A later. But if you look at the providers, it's basically a dream come true for them. Like they hook up some hardware into like our network, and they would get like all the jobs from all of these networks, and magically they would earn like rewards from multiple networks without them having to worry about staking, liquidity, or what is the protocol that they should be working on, or a bunch of the infrastructure work that they need to take care of by themselves. Now, let's take as an example the biggest DePIN network out there, which is Filecoin. So Filecoin today, by far, is the biggest network in the context of DePIN. First, because it provides like the biggest rewards to the providers, and also in the context of how much capacity of hardware there is, like it's by far the largest one. It currently backs 8 exabytes of capacity. 2,000, 3,000 providers are participating in this network. And it's generating the most block rewards out there. If you run Filecoin on top of our stack, you would get like, now these are like a bunch of flaws, but I don't want to get in the details on Filecoin. But if you run Filecoin on top of our stack, you'd basically get 80% reduction in terms of cost. So for Filecoin, you have two phases. One is the onboarding of the capacity and the data. For this cost, like it's 80% more efficient. And this was just by decoupling multiple roles, compute providers and storage providers. Then you get 5x cost reduction in terms of recurring costs. So this, in the context of Filecoin, is just keeping drives on. And you get like the possibility of getting additional rewards, because now like the stack is focused on allowing you to provide the storage utility, which allows you to get additional rewards. You can think of this like the MEV of DePIN, where you have rewards that are not coming only from block rewards, but rather are coming from people that actually need the storage, which was unfeasible just by having Filecoin by itself. So to wrap things up, if you're able to combine multiple networks, you're sharing the costs between multiple networks, and in that way you can increase the yields that you're providing to the token holders. You're helping like innovation, because now like you can combine multiple networks to talk between each other, because they are running like consumer machines. You have an open market, so like anyone can join, and ultimately this just helps like keep like the momentum and make the flywheel turn. I think that's it. Happy to take questions.
Questions, unless everyone has a complete understanding of restaking. No question. Can you talk about maybe the process for onboarding different DePIN projects and how that would work?
Yeah, actually there are like many complexities that I kind of intentionally left out here. But in order for you to participate in these DePIN networks, you need to build staking on top. So like the way that you actually are part of a DePIN network is by having a stake in the network. So if we want to integrate with a network, we would basically build a staking derivative for them. This staking derivative is likely going to have the highest APY because if you're sharing the resource between multiple DePIN networks, you're able to pass more of the rewards back, which gives you the highest APY. And yeah, we would have this derivative on Ethereum, which also helps these economies in the context of DePIN have more demand for their tokens, because ultimately there is an asset that is incurring in value on Ethereum, and you're exposed to the volume there. And it would also be part of our consensus by having it part of our treasury, because all of the rewards that we as a protocol are getting, we are never dumping, because ultimately we want to grow with the networks that we support.
And so how difficult is it for a project to create that type of derivative?
So the projects themselves care about their economy. So most of the projects, at least it's still very early days for DePIN, but what we have seen coming from Protocol Labs and building Falcon is that everyone is going to need to lock liquidity on the validator. So the definition of the economy is going to be on that layer. And what's going to happen is that all of these projects will need a staking derivative. So either they just build stuff on top of our stack by reusing the templates that we have provided and allowing our providers to actually run their stack, or it's going to be basically running validators themselves, which is super expensive, or letting the community kind of figure it out, which from the experience of Protocol Labs was not ideal. We basically wasted hundreds of millions of dollars of incentives just to bootstrap Falcon, which we don't think any DePIN project should do. We should all share the same resource layer, and on top of that, we should create a bunch of compute networks that are specialized for the individual jobs.
And can you also discuss the liquid component of it and how that works in detail? I think that's something that I think people understand staking, but the liquid piece of it is another hurdle.
Yeah. So usually in DePIN, maybe I take the example of Falcon, you need to lock for a particular amount of time. So you would lock for 6 months, 24 months. And for 24 months, your liquidity is locked in Falcon. Most of the people don't want to do that. Most of the people want to have liquidity that they can use for other things. And usually this liquidity also needs to be on a network where they can do stuff with it, like a DeFi and so on. So what we do is, other than just locking the liquidity inside the validator, we also make it liquid, similar to what Lido is doing for staking on Ethereum, where you can use that liquidity still on Ethereum, and you can unstake if you want, which is not possible by default, by doing that on just the providers directly. There are a few folks building lending in the context of DePIN, but that is kind of hard, because if you're doing lending and you're borrowing lending some funds to someone, and someone is borrowing from you, usually there is a fixed interest rate or something like that, which kind of does not allow you to unstake the funds. But because we are interacting with the providers directly and basically building the stack, running the jobs, we're able to unstake these funds either by terminating storage jobs or by doing less jobs on the compute side. So we are able to actually manage the risk and unstake if that really needs to happen. But looking also at what happened with Lido and what we are experiencing is that most of the time, you're really not going to unstake from the protocol, but rather you'll have a buffer on Ethereum that is able to match with the demand for staking.
And so if you're able to have liquid staking, presumably people will require a lower return rate, right? And so you would think investors and token holders would not demand the same level of reward if they're not locked up for 24 months, right? So, but yeah, you are able to fulfill that 24-month lock. So there's an arbitrage in between those durations, I would think, right?
Yeah, it really depends on how good are you at deploying the liquidity inside of the individual protocols. For Falcon, we're very good, because ultimately it's about figuring out the liquidity requirement for the different kind of jobs. I'm not going to get too much into the details, but for Falcon you have committed capacity, which is 1/10 of the liquidity requirement, and verified capacity, which is 10x. So if you're playing around with committed capacity versus verified capacity, you can actually be super close to full capital efficiency. which you just can't do like with the lending, because for lending you need to have a very big buffer, otherwise you run into bank run problems, which we have seen already in the Falcon ecosystem. There were protocols doing lending that basically experienced a bank run. When the crypto market went up, people wanted to exit, and these protocols just couldn't pay back like the stakers, and they experienced a bank run.
And that, I guess, that can't happen in the liquid staking only because there isn't the obligation to pay. It's more of a best efforts in terms of liquidity. Is that right?
So it can't happen in staking because you are staking the liquidity inside the protocol. And when you stake the liquidity inside the protocol, you also build the strategy on how you're going to unstake it. That's why it cannot happen. When you build the liquid part on top, they're just making it liquid. And then you use these strategies of unstaking from the protocol to actually do it. If you do lending, you're delegating the staking to the provider that would then like lock that liquidity. As far as you're concerned, like your interaction with the protocol ends there. Like you are not really interacting with the protocol, but delegating the responsibility of locking the liquidity inside the protocol or staking. So it's not really staking in the context of lending, it's lending.
And so then what you're implying is that there is a cost. And so you build in exit scenarios to de-stake. There'll be a price to that, and that's a price that your liquidity demanders or liquidity desirers will be comfortable paying. But at a price, they're out, right?
Yeah. And to be a bit more specific and maybe give an example, so let's take compute and let's take storage. For storage, like you have these ways of basically unstaking by not providing the storage anymore, because storage is a continuous operation that you do for the network. Well, for compute, you can basically reduce the amount of compute that you're providing. So for example, in the context of Fluence, you would just stop providing Fluence resources to the Fluence network if you don't have the liquidity. It's easy as that. Like you're not locking for like years. In the context of Falcon, it's basically just reducing the capacity that you're providing for the Falcon network. But again, if you're doing lending, you can do none of this because you're not the one actually locking the liquidity and interacting with the protocol, but rather it's the provider that does the act of providing the utility that does the staking for you.
Can you talk about scale? Like if DePIN goes to the level that we all expect it to go, this staking will be an enormous business. So can you kind of help frame context size, either in a Filecoin or just across the whole DePIN ecosystem? Like where do you see this going?
Yeah, so let me zoom out for a second. So like if you look at DePIN, like each of the DePIN networks is basically a product on AWS. So like you can think of Fluence as Lambda functions on AWS. You can think of Falcon not as S3, but maybe as a cold line layer of S3. So Falcon is not like super good for hot storage. Probably we'll see other protocols doing it. And if you take like each of these products, it's probably going to be a protocol solving that product. And if you take the size of AWS, that's just one provider. And if you look at what we're doing in crypto for like other things, for example, like Ethereum, even the size of the financial side is larger and can be larger than like the entire like centralized financial institution play, because ultimately it's an open network. So like you're not attacking like a particular horizontal in a particular market, for example, the US or European market like AWS, but you're basically covering the entire horizontal. So like it's also going to go to China, it's also going to go to Russia, it's going to go to all these places where like AWS cannot work today. So you take and basically what this means is that you take probably the size of AWS and you multiply that by 5, and then you like look at that market, and that's probably just the beginning. And it could be even larger with all the demand that we're getting on the compute side.
I mean, that's obviously vast. And how do you think about that in terms of scaling your protocol and your business to meet that demand?
Yeah, for us, it's really like being very clear on like the rewards that our providers get, because ultimately for us it's enabling super efficient hardware. And if you want to enable super efficient hardware, there is no stuff like, oh, we are going to airdrop you like whatever, maybe at some point. folks are trying to survive, and like when they have scale of 200 petabytes, 1 exabyte of capacity, like 10% really means a lot to them, and they need to know that exactly how much they're going to make, because it's a low-margin business. They are providing just the hardware, and they need to like run with their business. And usually it's like 3 folks that are managing a big data center. Like it's not like this big whatever organization like Coinbase doing staking. So like in the context of DePIN, like staking is going to be very different, because you need these resources. You need to run the data center. You need the hardware. You need the actual physical space. So for us, it's really being clear on unit economics, making sure that our providers are not incurring any risk, absorbing like most of the risk from the crypto fluctuations, which is kind of preventing crypto from being efficient, because like if you're going to be out of business like the next cycle because like you did not plan well like with your block rewards, we're really not going to get there like in 5 years. Like it's going to take the cycles to get much weaker for DePIN to even be possible. So like we don't think that's the right approach. That's why we want to kind of buffer like all the risk from the token fluctuations and reward providers in usually stable coins, because that's what they prefer.
You're giving a preview of my talk, but what you sort of implied this, but so make it more specific, advice to people starting protocols or interested in launching in the DePIN space along the token economics line that you were just referencing.
Yeah, I would say like don't take the hard route, which is basically building like everything from scratch. We at Protocol Labs made many mistakes, like probably you can learn from us. You can learn from other protocols, like many protocols failed, like Golem failed to a degree, like haven't seen much. Like many compute protocols already failed. And what you actually want to do is like define the workload, the focus on your community. So for example, if you want to focus on rendering AI, like focus just on that. Your job is to actually create the tooling that will onboard like more demand for that particular job. It's not to work with the providers. It's not to like do all the things that all these other protocols have done already, but it's rather to really focus on bringing more demand. And this goes through the tooling. Like the tooling needs to be much better. And we have seen that at Protocol Labs, like the tooling is essential. Like you want to onboard, you want to like be fast on like how you're enabling the final utility, which is storage. And everything else, like try to like delegate that to someone else. Try to like use stuff that is already there. So if you can use like hardware that you shared across like many DePIN networks, do that. Like it's gonna save you so much cell pressure, and you can also kind of postpone like the token launch. You can do like things on your own, like by actually just like having less cell pressure on your economy.
How many token or how many storage, compute, other type of projects do you expect to be live and at some level of scale in say 5 years? Do you think it's a winner take all? Is it very diversified? How do you see that ecosystem building?
As I mentioned before, like every product that you see on AWS, that's a network. So like I think even that is kind of not true. Like every of these products have like a sub-product inside. So like we expect thousands, which is why even though like we started 3 years ago, we didn't want to focus on the network itself, because we were like, it's going to be like so much competition there. Like let's just enable these networks by providing the resource, because everyone will need the resource. So like we expect like at least 100, probably more than 1,000.
And any particular parts of that stack you think need products sooner, or you would like to see someone building something in? Or you see opportunity for someone who wants to launch a protocol?
Yeah, I think like there is a big demand in the context of training big neural networks or LLMs. So at least use cases that we're focused on is enabling people to read from Filecoin. That's actually a lot of compute just to read from Filecoin. Pushing that through Fluence, for example, doing ETL pipelines, and then pushing that to the next thing. Like building the ETL pipelines and all of that stuff needs to be built. Like that could be a protocol running on top of Fluence, which is a separate protocol with a separate economy. Like most of these protocols are going to interact through the economies at the end of the day.
Any questions from the crowd? I've monopolized this for a while. Any other questions? No more questions from anybody. Oh, yes, question.
Hi, short question. It seems that you're able to connect to the Filecoin virtual machine and Ethereum-based virtual machines. Is that the limit today, and do you intend to broaden that out to other types of smart contract networks?
So ultimately, all the VMs are more on the economics. So like we use, of course, the FVM because like that's the way that our economy interacts with the Ethereum economy. But all the compute, all the storage, it's kind of not on the FVM yet. Those are like messages on the Filecoin networks. And like, sure, those are going to get more structured. And by the way, like I think there is a lot of space there for people to actually work on that, like just structuring like storage deals, structuring compute deals, like all of that needs to be somehow organized for people to have like a Ethereum-like experience in the context of DePIN. So right now, like we're mainly using these VMs to have like to allow staking from Filecoin to Ethereum, because ultimately we want people to be able to stake on Ethereum and use that in DeFi protocols and keep increasing the yields that they can possibly get by increasing the utility that they get from their liquidity. But it's not yet on the compute side. It's basically just for economics.
Short follow-up, and when do you add Fluence network into your offering?
So Fluence network is going through like a slow ramp up of providers. They are doing that by kind of keeping liquidity requirements low in the beginning just to get more providers. We have everything ready to launch our stuff as soon as they actually increase this capacity, and like Tom can comment more on that, but the capacity is going to be 10x more. When there is 10x more capacity requirement, there is also more liquidity requirement. At this point, by ourselves, we own enough Fluence to actually back the nodes that we currently have on the network.
Thanks.
Great. Any other questions? All right. Well, let's give a round of applause to Vuk. Thank you. And next up is Kai from Impossible Cloud, coming right up.
All right, hello everybody. Great to be here, great to have you all here. So today I'm going to talk about what we see as kind of the next evolutionary step, next generation decentralized cloud and DePIN platforms. So very easy to start with. Like this started all ago. Obviously, you can argue that Bitcoin itself is kind of a DePIN, but of course, never back in the days, nobody talked about it. Where this all started really is then in this what we call phase 2 with Filecoin and some others, Akash a little bit later and so forth. What we see as a lot of supply-focused DePINs. So basically, DePINs in these days started building hardware networks with a tremendous success, right? And it was a lot of bootstrapped hardware in the beginning. Some still focus on consumer-grade hardware. Some have already enterprise hardware. Most of these DePIN networks that started there were all focusing on one single use case, storage or compute in the case of Akash, Helium, some others, and so forth. And that's even before anybody was still coining the term DePIN, but this is kind of the starting point of this. Then this phase 3, where just recently, I would say, a couple of years ago, DePIN started also to think about what about the demand side, right? So in the end, this is only going to work if we have real-world products, if we really sell to end customers. And yeah, so by now you have several hundreds DePIN projects already, probably close to 1,000, 50 billion market cap from the Messari report that came out beginning of the year, and they keep on updating this, so this is really great in conjunction with EV3. Also, in this phase, you saw the first really DePIN specialized VCs coming along, and a lot of DePIN networks are trying to ask more the question, can we get customers, enterprise customers, into our networks and really ramp up revenue. Of course, in order to do this, you need a lot of product development, and that really takes some time. And we are at the brim of really now entering phase 4, really challenging the cloud. And of course, this will take some time, but this is where we foresee the future is going. So really challenging the hyperscalers, the AWSs of the world, the Googles and the Microsofts and so forth, really challenging them down the line with enterprise-grade hardware, networks that are really capable of serving many, many different use cases, and make this accessible for enterprise customers, multi-service. What does it take to really get there, and where are the differentiators? So if we compare very briefly centralized cloud service providers against Web3 service providers, and also if we make the comparison a little bit against like the first wave of the DePINs and where we see the future is going. Of course, on the Web3 side, you have a lot of Web3 advantages. Is this the reason why we are all here, right? So privacy, data sovereignty, no single point of failure. So lots of advantages that decentralization brings. Centralized cloud service providers, they don't have it. Also like this win-win opportunity, really building an ecosystem together, really having lots of projects integrated and also sharing the overall value is not happening in the CSP space, and that's of course a big part of the critics that's coming along with it, like this oligopoly that is really dominating everything there. The multi-service architecture, from our perspective, is a really, really important step, where at the moment DePINs are not really there yet. If you think about this from a customer perspective, of course, the lock-in effect of the central cloud providers is so big, because you can just have one place, you go there and you have storage, compute, all types of computes from EC2 to CDN. Like AWS has like 250 services, and that's pretty compelling to a lot of customers. And along the lines, this is needed in the future to make DePIN successful as well. You need somehow to make this offering to enterprise customers and have these multi-services at hand to use. Otherwise, a lot of customers will not switch. Enterprise-grade hardware, of course, is super important. It's tremendously hard. I would say it's not doable to build out of just commodity laptop PCs or whatever a real sustainable enterprise-grade product. And for that reason, we think we should focus a lot on enterprise-grade hardware. Once these networks are built, maybe you can add other hardware as well, but the requirements for enterprise customers are pretty high, and that's the reason why you need certain type of hardware. And then Vuk also talked about like how to access the market, the demand side a little bit. The tooling that's needed to access the demand side is really intensive. So there's a lot of stuff that you need to put in place. Otherwise, you will not attract any customers, right? So for all different use cases, there's a lot of software tooling needed. And that's the goal, what we try to build, not of course by ourselves, but we try to build an ecosystem where a lot of other projects can really plug into. Basically, a multi-service platform for any type of cloud service with super high performance. Compliance is for enterprise customers super important. I talked about it. And that will really have, from the get-go, customers and substantial real-world revenue. I'm going through the stack here, step by step. This is just like how we see this in very easy terms, but basically, you need to have, if you have the customers on top, you need to have the full stack with all different services and protocols and so forth in between, all the way down to the hardware. And there's a lot of stuff that needs to really come into play. Otherwise, you won't have a successful product. But let's run through the swim lanes one by one here. So the first part, enterprise customers. I mentioned this a couple of times now, why we said from the beginning we want to focus on enterprise customers. I think in the long run for the cloud, this is by far the much larger revenue potential, of course. And this is something where AWS has its profit center mainly, and this is what needs to be attacked, right? And then, of course, the requirements getting into this space is super tough, but once you're in that space, the competitive advantages are pretty big. Also, the whole ecosystem flywheel in the enterprise space is super big because you have lots of other companies that you can cooperate with, and believe me, there are many, many out there, also in the Web 2 world, companies making a few billion revenues who really want to win together against the hyperscalers because they're all threatened by the very big tech companies. On the lower right, you basically see the amount of hardware that is needed just based on the AI trend right now. So the additional hardware that's needed just for serving all the AI workloads. And basically it breaks down always into like network, compute, and storage. And these three components are needed at massive scale, obviously, in the next years. But somehow you need to orchestrate this in the right way. The second layer that is super important in order to really get to customers and customers' demand, and without this demand, nothing will happen in the future, what we call market access tools. Of course, every DePIN at the moment that is trying to get to demand is developing it by themselves. We did the same thing, and it's a lot of stuff, right? So you need everything from the security layer and IAM systems, identity and access management, into other parts of firewalling and logging and observability tools, also some CRM tools in order to onboard customers like partner portals and so forth. Also in that layer, what's super important, if you are trying to sell products in the cloud industry, it's a super well-developed ecosystem with many, many partners, integration partners, distribution partners, lots of companies around the world, as mentioned before, who make like a couple billion revenues. These are partners that we integrated already, that you see here on the slide, and partners that are for any DePIN in the future, I think, necessary if you want to really go for enterprise customers, right? Probably depending definitely on the vertical, on the service that you're offering. So potentially for storage, some partners might look a little bit different on the integration side than for computational jobs and so forth. But basically, if you want to really address enterprise customers, you need to integrate with a lot of these tools. And that's also one of the ideas here in the future. Why not have an ecosystem where not everybody is building again and again the same stuff, but maybe where you can share certain things that have been built once, right? So potentially offering these market access tools also for other DePIN projects that really want to go big on the demand side. So they don't have to build it all themselves, but they can more focus on the software layer, for example, below. Then there is like this big service layer, right? So where you have multiple services, as discussed, like AWS offering around 250 services right now. We started deliberately with storage. Storage is kind of a foundational layer, one of the three foundational layers that you always need for any kind of job. And it's a hard one to do because the data has a lot of gravity. So usually it's much more efficient to do a computational job where the data is. So basically you move the computation to the data and not the other way around, which is called like this data gravity. Moving data is super expensive. But of course you need a lot of other services in order to be attractive for enterprise customers. And that's also where we are planning to open up this ecosystem now. So on the object storage side, there are a lot of customers using our product already. So like 20 million files being uploaded every day, probably 100 million by Q3 or so. But it's just like a tiny little piece. I think in the end, it's supposed to be an ecosystem here where other DePIN projects can really build additional services. Like let's say, Vuk talked about GPU AI, for example. So basically, you need on the software layer, probably some PyTorch and some TensorFlow and some Ray maybe, and then you build on top through the market access tools, and you have a product basically for the customers. And I think that's the beauty of Web3. We can build things together. And that's the way how we can dethrone the large hyperscalers. So basically adding a lot of services in this layer. And then a lot of the magic is happening on the 2 layers below, what we call the Impossible Cloud Virtual Machine and the Impossible Cloud Network Protocol. So the virtual machine basically is a cloud runtime that orchestrates the hardware that is supplied into the network. So basically it's fully programmable, where service providers can program and access the hardware that is on the very bottom layer here. Basically 4 components. I'm not going into all the details here, how this is done. But ultimately, this is enabling the service providers, other DePIN services and so forth, to access the hardware, the provisioning, and everything that's needed. On the protocol layer, the protocol is basically a node coordination and network formation protocol. So it has an incentivization layer, of course, a tokenomics built in it, and kind of a marketplace between the hardware and the customer, and like with pretty typical things in place where you have like also collateral and so forth for the hardware providers. Maybe one thing to mention here on the tokenomics side. So there are of course different tokenomics needed for different services. Just to illustrate like the tokenomics very briefly here for hardware on for a storage class. So basically, what you might not expect, but depending on the utilization, of course, the reward is increasing up to a certain point, and then it's decreasing. Why? Obviously, when you have a lot of storage in your node and it's utilized like 80–90%, you want hardware providers to add more capacity, right? So otherwise they would be full, and this would be not ideal. So, but these types of incentivizations are built into the network protocol, depending on the service here. And one additional part of the network protocol, which is kind of interesting, is the approach in terms of verifying that the job that is done is correct. So this is, I think it's coming from A16Z or whatever, this DePIN verification problem, where you always have kind of a problem how to prove secure compute or how to prove storage that the hardware provider is really doing the job as supposed to be. And we tackled this in an evolutionary approach. So we started very traditionally with SLA contracts, so real-world contracts in place that you can audit and so forth. Of course, on top of that, there is some collateral that hardware providers can get slashed. And then the next evolutionary step from our side will be SLA, what we call SLA oracles or watcher nodes, validation nodes that we will release in the network pretty soon. And they can do all kind of verification jobs. But also what we want to have in the ecosystem here is what we call bring your own proof. As you know, there are a lot of DePIN projects that are developing a very, very specialized proof for a certain problem, right? So for a certain machine learning problem or for a certain other problem. And the idea is, again, let's build this together. I don't think there will be one network that is building all the different proofs. I think it makes a lot of sense to be here in an open ecosystem where other DePIN projects can bring their proof and then access their hardware in a certain way where according to the proof, hardware providers might get slashed or not, or rewarded, right? So this is a big part of it. And in this whole layer, especially on the Impossible Cloud Virtual Machine, we are expecting a lot of open source community starting to grow, where I think a lot of places to really make this all happening. And then on the very bottom layer, you have the hardware providers. Yeah, I mentioned the data gravity before, why I think being close to the storage is pretty important. I think a lot of other stuff is important here as well. So having the hardware, the storage in the right geolocation, for example, in the right compliance, the right data centers with the high performance, the networking, the connectivity is super important. So we are always looking to operate out of tier 2, tier 3 data centers in like the big hubs of like Frankfurt, Amsterdam, or US East Coast, and Ashburn, for example, and so forth, where the big internet hubs are. So this really helps to build the network at speed. And this is where we are looking for also like onboarding more and more hardware providers now. GPU as the next class obviously is super interesting. But yeah, I think from here it will grow quite a bit. And before I close, maybe as a summary, on the left side, a little bit like to illustrate how we see this future happening. So what you can see on the left side at the bottom is like the central Web 2 cloud providers. Basically, it goes from left to right, like from single servers like Dropbox, Backblaze, Wasabi, so forth, to the right side where you have a really holistic cloud offering with like multi-services and so forth. This is all done in a very central approach, of course. And then you see on the Web3 side emerging, which I think is super great, since several years now, mainly a lot of very focused single service offerings in the storage space, a lot of stuff happening in the GPU compute space, other spaces as well. And what we see in the future as the holy grail kind of is the top right corner, where Web3 needs to develop into in order to really get mass adoption to the DePIN ecosystem, right? So basically what we want to achieve is connecting like different services together to have a holistic multi-service cloud offering in a decentralized way. And I think the more we get there, the more of the market, the Web 2 market also, enterprises will move and use this technology and move away from the bottom right corner, the hyperscalers. So let's partner, let's build this together, and yeah, I'm really excited about this future. Thanks.
Fantastic. Thank you, Kai. Do we have questions? Do we have any questions for Kai? Yes.
Thanks so much. Thanks for breaking it down into those swim lanes. I'm curious, like you kind of said, you want to ultimately take on the centralized providers with services that mirror what they offer today. You also outlined the complexity that it would take to take them on. Could you break down a bit kind of the cost structure and how it's different for you versus the centralized providers? Because ultimately I'm thinking that if you want to compete on price, you need to at least match their cost structure. I'm sure they have like thick margins and stuff, but it looks like there's a lot of, let me just call it decentralization tax, right? You have a lot of overhead that you don't have as a centralized provider with maybe some additional benefits. But yeah, just kind of like help me understand what's the decentralization tax in terms of cost structure for providers on the network.
Yeah, so good question regarding the efficiency of decentral versus central in this space, because customers, as you mentioned, obviously are cost aware, right? At the moment, I would say it's exactly like this big tax on the central service provider. So a lot of customers really pay a heavy tax on that. A lot of money really flows from Web 2 enterprises into their cloud infrastructure. A lot of companies are starting to complain, by the way, that they are so locked into the cloud. They started very, very cheap. I don't know. You can start even like with 100,000 euros credit or dollars in credit, and then they get sucked into the system. And once you realize your bill at AWS is super intransparent, by the way, and then it's really overboarding. I believe in the future you have no problem of switching, which will always lead to a system where you can have go with the smallest price for the best performance, for example. I think down the line, decentral is even more efficient than central. Probably it depends also on certain use cases, but for example, I have Cloudflare here on that picture. Cloudflare is a Web 2 company that is having a pretty distributed architecture. So they have probably 20,000 servers and several thousand locations. And running and maintaining this as a central company is super OpEx heavy, right? So, and on this regard, I'm expecting that running a decentral network is way more efficient than these types of networks. Maybe in the future, it's not like a 0 or 1 or black or white. Maybe also depends on the type of use cases. I'm anticipating that for many use cases there is no choice because you need a very decentralized network. Again, Cloudflare, they started off as a CDN network, so you have a lot of proximity between customers and the data. Because it's a very distributed network. That's physical reasons why these types of networks are much faster and are imperative. You need it, otherwise you cannot serve your customers. And the same thing is happening for many, many more use cases. Like if you think about AI inference, for example, I think distributed networks are superior. So it's not only about competing about cost, it's also about like being superior for a lot of use cases. AI inference probably is not the only one. For example, if you want to ingest real-time data into an LLM, then let's say you have, I don't know, private data in a Confluence database in your enterprise company or whatever, it doesn't make sense to move the data to the next central hub of AWS and then compute it there. Of course, this is probably the only way how you can do it today, but in the future it's much better from a cost perspective to move the computational model to where the data is. And for that also, again, you need very decentralized networks. Autonomous driving and so forth. I think there is a lot of need for decentral networks where you don't only compete on price. And again, like the central providers, I think they have a hard time building these decentral networks. So a lot of advantages, maybe not that in the very near-term future AWS will completely go away, but yeah, let's see.
Fair enough. I don't think we're betting on AWS going away in the near term, but we have the same goals, that's for sure. Well, listen, let's give a big round of applause to Kai. Thank you. And we now have a coffee break, so 10-minute coffee break, and then there are 3 discussions, 2 talks and 1 panel. So 2 talks, 1 panel, and then it's lunch. So quick coffee break, get energy for the next couple of talks. So enjoy. See you guys back here in 10 minutes. So thrilled to have him here. Mihai's from... So why don't you guys? I got cut off. You guys can finish it. But we have Mihai from Messari. So if you guys don't know 1KX or Messari, you may be in the wrong room. So I'll turn it over to them to give their introduction from their quick bios, and then get into a discussion. Thank you, guys.
All right. Thank you so much.
Round of applause. Oh, yes, there we go. Perfect.
Hi, everyone. I hope you're all well caffeinated and that you're ready for the next fireside chat here with myself, Mihai, and Robert. We're going to speak about value in DePIN. My name is Mihai. I run protocol research at Messari. I focus on DePIN, and if you're wondering when DePIN actually started to become more popular, it was actually in 2022 when Ryan Selkis had a survey in Twitter trying to establish a term, an acronym for the whole field. And it turned out that DePIN was preferred by most of the people. So here we are at a DePIN event, which is quite special, and I'm very happy to see you. Together with me, I have Robert. Why don't you go ahead and introduce yourself?
Yeah, hi guys, I'm Robert. I'm with 1KX. I'm a researcher, mostly doing economic and token design. But my area or domain of research used to be or is DePIN. That's why also us two want to chat a little bit about the value and the current state of DePINs from an economic lens. And why don't we jump right in and start with the first very high-level question, maybe for you, Mihai. How would you basically define value, or how do you see the value of DePINs?
Yeah, so I think as many things in life, defining value is actually hard, but I think it's value is actually in the eye of the beholder, and the beholder here can be either the market, or can be the users, or can be actually the ecosystem participant. So if we move along, we prepared a couple of slides here, from the perspective of the market, so everyone is interested in the market value of DePIN. So at the moment, we're somewhere between 50 to 60 billion. However, DePIN is projected to grow about 100x from now, so not really 1KX, but 100x from now to around 3.5 trillion by 2028. However, we're not here today to speak about market value. We're here today to speak about economic value, and especially about how value is actually being created, and also how it is being captured. So if we move along value creation, there we can see that in order for businesses to actually gain traction, to gain adoption, they have to be 10x better, cheaper, faster. So we've prepared one example of a better business. So essentially having great coverage out there in terms of network coverage. But then at the same time, if you think in terms of cheaper, we have examples out there in terms of video transcoding, in terms of decentralized compute, in terms of decentralized storage, where DePIN achieved already 10x cheaper mark. All right, moving forward, I will give the word to Robert with respect to some considerations on how actually value is being captured nowadays and who captures that.
Okay, thanks. When talking about value capture, for me there's two considerations. It's a little bit about like who captures the value, and then also like how can you capture the value. Maybe when we think about the who first, let's maybe take a step back and understand, like, in any DePIN, if you dissect them a little bit, like Vuk earlier also started diluting into that, into the different functions or roles that any DePIN has. It pretty much can be put into this diagram here. And let me quickly walk you through what I mean with the service node in the middle, right? These are the guys, the storage providers for Filecoin, right? They provide the hardware, they provide the service essentially that the DePIN has. But then whatever they do, typically or ideally, right, there's a user who wants to store something. And so they request some work, they request some service with a service node. Then, however, since it's decentralized, anybody can do it. So how can the user know that the service node actually did the work? Well, there's a validator or watcher role that does that. And typically, the whole thing is tracked with a decentralized ledger, right, the blockchain. So this is the accounting layer. However, the accounting layer is not just the blockchain because it also includes the accounting logic, which kind of like says like, how do you actually aggregate and store these track records of work and payments? Right? Because ideally also the user then pays for the service. And there's two more roles on here. Sometimes networks decide to even add a little middle layer between the user and the service node, which is a gateway, and which is just like some orchestrator or load balancer, as you can imagine. And yeah, some networks, or a lot of networks, have staking mechanisms, and then there's this like delegation function. So this delegator role also comes into play. But yeah, talking about capture, sorry to interrupt. When you go through these, is a little bit like, first of all, the user kind of like pays to the service node. If there's a direct connection, then the service node actually is able to capture the value, right? Gets the value. The validator typically, doesn't capture much unless sometimes, like Filecoin, for example, storage providers are both the service node and the validator. They have both function combined, so technically the validator also captures value. The accounting layer captures some value in forms of transaction fees, but here Filecoin has a proprietary blockchain, so Filecoin network gets something of that. Other ones use Arbitrum, LifePeer uses Arbitrum for settlement, so this goes away because it's outsourced basically, right? It goes to the Arbitrum sequencer, not to the LifePeer network, which is fine, right? It's just like this is the way it is. And maybe as last point, in lots of DePINs, I would argue nowadays, there's even the user capturing most of the value because we're on the monetization front. If you look how things are priced, they're super, super cheap. So the most value is actually if you're a user and you just request a service. If you store on Filecoin, it's, I don't know, Book probably knows the exact prices, but it's probably roughly zero. I don't know. So yeah, long story short, I think when I talk about who captures the value, I would say it's kind of like right now the person who has the point of sales with the user. And it's either the user himself because the prices are so cheap, or it's a gateway or the service node who kind of like directs the work. But yeah, I interrupted you, sorry.
I actually wanted to ask you one question. So I agree that on the user side, you have a race to the bottom when it comes to cost for the end cost for the user. But in terms of like the network or in terms of the protocol, who actually captures most of the value here? Is that the service node? Is that the gateways? Are those the delegators, validators? Who is actually percentage-wise the actor that captures most of the value?
Yeah, that's tough. I would say that really depends on the network and the network architecture, right? Because again, there are networks that don't even have a gateway, and then in that case, it is kind of like the service node. Gateways are a very interesting concept, and we might get into examples where if you look at HiveMapper, Demo, Pocket, they have gateway functions, and these gateway functions are the ones that monetize. Demo are the ones who like collect the data from the service nodes, like the AutoPIs and the cards that generate the data. But then Demo Gateway, which currently is run by Demo, the company basically, makes sure that they sell it to whoever wants to buy the data. Similar with HiveMapper. So that's why I would say currently value capture is happening on the gateway. However, the caveat to all of this is like we can probably also debate a little bit, okay, how much value is there actually to capture right now? And I don't know if you want to go more into the how to capture value actually.
All right, so we've seen the intricacies of who captures value. So We were thinking to go over one specific example about both Robert and myself have been thinking about. We've picked this specific example because it is just very, very interesting from the perspective of both value creation and value capture. And here we can see Pocket Network. We also have thoughts about many other networks out there, but Pocket was one of the first ones having something interesting out there. So if you look at the black or like the gray line, which is picturing the number of nodes, you can clearly see in the beginning of the network's life that they started to pick up over time up until they reached an upper limit. And as many other DePINs, what happens is that you use tokenomic incentives in order to be able to bootstrap the supply out there. So that's why the number of service nodes increased up to a specific level. And then very interestingly, with the green line, we have the total number of relays there. In other terms, the relays actually signify what is the demand for the services offered by Pocket. And you can see that the green line pretty much follows the supply. And in this case, Pocket has been able to bootstrap the supply to a specific level, and then the demand over time followed up or like caught up on this. However, what we can see is around Q3 or Q4 of 2023, something interesting happened, and you can see like a drop in the number of total relays out there. So Robert is smiling, so I'll give him the word on explaining what actually happened over there and what are some of the more intricacies of the mechanics behind that.
So you get the positive part, I get the negative part. What happened there, right, is something that I think a lot of DePINs actually face. Is this, up until then, it looked very much like the DePIN flywheel story everybody will tell you of like, bring in the supply, ramp it up, it's ample, it's good UX, people will come, will use it, and that's what the green line also showed. The one thing that you need to keep in mind, though, is when we talk about value capture, is utilization demand is not the same as monetization, right? Just because people use it doesn't mean they also pay for it. And here we said, like in Q4, actually, what happened is the Pocket Network decided to say, look, we had very generous free tiers until now. Let's stop that and let people pay more for it. And you can see what happened to the demand. It dropped significantly. It stabilized. But this is something for sure to keep in mind, right? Really important value capture. Just because you have like trillions of users or whatever of requests, if they're not paying, you can ask yourself, okay, how can I capture value, or what might happen then? And yeah, maybe to move on that topic, when we talk about value creation and value capture, the question I alluded earlier on is like how to actually capture value. And there's an interesting topic that typically people don't like to talk about, other than Vuk, who mentioned cost. And this is cost, right? And Pocket Network had something very interesting, which I would see as like a transition topic between value creation and value capture, because if you can create a supply on very efficient cost base, this is better value creation than just creating the supply, right? And here, maybe just to show you what this red line means, is some cost estimation that we did. No worries, we'll soon share more details on that, how we did that. But for now, just believe me that the numbers are somewhat okay. And as you can see, right in the beginning, incentivize the node count, supply goes up, cost of the network goes up, because more nodes means also more cost, because each node has the same cost, roughly, or right, caveats aside. But then node count goes down and the cost go down. And this trickles down until, Q3 in 2023. And then you see a drop, actually. And the interesting thing that happened actually in 2022, early 2023, is the Pocket Network. There was huge discussions that the node operators realized, oh, we have all these nodes, but we're running very inefficient because, we don't get any income. We only get tokens, and the token price goes down. We're running red. So what they did, they realized, okay, we need to be more efficient. They figured out a bunch of initiatives, GeoMesh, Lean Pocket, etc., and made their nodes more scalable. And so the cost per node went down dramatically. So that used this first drop. And yeah, just the second drop even followed afterwards, because as I alluded earlier, there's this gateway function, which is kind of like funneling in user requests for relays and then passing it out to the node runners. And this was one function operated. It was operated on GCP, and this is very costly because tons of egress volume is like how bandwidth cost doesn't scale. But they started to decentralize it, and that helped reducing the cost even more, and also sets them up to now even scale.
At the same time, as we see the decentralization of gateways, one can also overlap the decrease in the number of relays served. Can you explain a little bit more over there? Why do you see that correspondence between the two of them?
Yeah, I mean, that was kind of like happening at the same time, right? They decided to say, okay, we want to stop with the free tiers, because when you just have one gateway, you can say, okay, it's our gateway, we have the free tiers. But now we open up to more gateway operators, and then it's like, okay, I have a gateway, you have a gateway, who decides to give out the free tickets, basically? So then you say, like, okay, let's both of us not be able to give away free tickets. But instead, we say, you know what? If you're running a gateway and you're running a gateway, you can sell this service at any price you want. You can give it away for free if you want. But the back end, the service nodes in the back end, you pay them a fixed price, 85 cents, I believe, for 1 million requests. And this way, again, talking about value capture is a nice mechanism, because now what happens is like the Pocket gateway run by the network early on was outsourced. Like the sales team is outsourced. You say like everybody can become a sales team. You can make the prices, you can make the deals with whomever you want. But the network, the infrastructure you're using, you pay us a fixed price. And yeah, this is basically what all happened in Q4. Yeah, just for information, this blue line is roughly what you can think of, because decentralized gateways also means we don't know exactly how much they charge, because there's several gateways. What they price, I don't know. But when you look at market prices, it should be in the range of the blue line here.
Mm-hmm. All right, so we see here that we have mostly like the red surface signified the costs, and we can see that the costs continue to go down over time. However, what is interesting is the blue part, down the chart out there. And the blue part also exhibits some novel behavior over there. So we can think in terms of demand, and we can think also in terms of revenue or fees accrued. Can you relate both the costs to actually the revenue, the monetization that is happening currently in Pocket?
Yeah, this is. Oh yeah, sorry for all the lines here. But essentially, the blue line is what the gateways potentially charge. I mean, they can take a price of $5 per million requests. That's the solid line. In Fura Alchemy, they are even more expensive. Or you can take $2.5. That's the dashed line. But what's really more important is that this black line at the bottom. This is the 85 cents that they will pass to the service providers. So that's basically the cost of the gateway of reselling the services, so to speak. And this is burned. That doesn't matter so much. But this is essentially the income to the service nodes, because they have staked Pocket and they benefit from that. I think I'm not sure, are we on time actually? But one thing I feel very interesting. Once you make these exercises of like, okay, who are the participants, who creates the value, who can capture the value, how can we even adjust our model, right? Like Pocket adjusted the model over time. Now they have these decentralized sales teams, their gateways. The cost base, they made their cost base efficient. Now we can say, okay, currently I think Pocket has like 350 million relays per day. Let's say it's 500 million, and say it's 5xing. And take some price of like $5 per million requests that they do. Obviously, if you scale up your demand, your cost base also increases. Ideally, not so much. then you did a good job. And here it actually happens, right? The service nodes, we talked to a lot of node runners, they told us like, yeah, they can scale up without much additional cost. The main cost driver when you scale up is bandwidth, because egress volume, it basically is linear. So this is what puts up this like red dot there. But as you can see, the positive news is like, okay, if you can basically have the red dot there, the blue dot is still above. So technically at that point, the network as a whole is profitable.
Okay. So you say 5x in demand equates to profitable network. Now we have various players in the network. We have gateways. We also have service nodes. Is it going to be profitable for everyone?
Yeah, well, yeah, no. That's what it says here, right? Like this is our first attempt to just understand like when is the network as a whole profitable. There's obviously still like so many actors. I mean, there's like over 100 service node providers. Each have different cost profiles, so you can't tell for sure each one. But also you're like, okay, the gateways, if they sell their service for like $5 per million requests, they need to pay 85 cents in the back, plus they have their gateway operational costs, which typically will be largely bandwidth. From the modeling we did, we understood like, okay, they will likely be profitable if they can charge a $5 cost. The service nodes, however, their operational cost, as you can see, is this empty dot, the empty red dot. They will only get 85 cents, which is the very bottom of this blue line. So they will still be in the red overall. However, I strongly believe that larger node operators who are have very good economies of scale will be profitable at that time. It's more like the smaller fish that might not be. But yeah, I mean 5x. As you said, like 100x is the goal. So at that stage, everybody's profitable for sure.
Yeah, so by 100x, probably most of the networks will become profitable. However, to reach 100x, there has to be more out there in terms of monetizing the services. So I think currently most of the DePINs monetize their services through a fee. However, do you have any considerations on what are other monetization avenues for protocols out there?
I mean, yeah, first of all, really, I like this idea of just like decentralizing your sales teams. I mean, sales teams at all is like something no one talks in DePINs, I would say. I think in the early days, Filecoin maybe had some sales departments. But this is something where really, when we look back at the roles, right, DePINs so far have been really good in orchestrating the work, the supply, coordinating everything. And I know, it's a heck of a job to do that. But as also previous speakers said, like, okay, we are at that stage now. Now let's think about, okay, how can we foster demand? And yeah, putting an incentive model like gateways is one way. The other way is for sure also expanding your product offering. Pocket does that, right? They don't only serve RPC relays now, it only goes towards AI inference. AI inference is typically the one piece everybody goes now. Like LivePeer just yesterday announced the AI subnets, which is similar. Right, you can no longer only do transcoding jobs with LivePeer, you can even do AI inference for video generation and image generation, because they have all these GPUs laying around anyway. So this is another avenue I like a lot, that DePINs expand basically their offering to foster demand. But yeah, down the road, it will be interesting to see, because I agree that probably, if we talk about 10 years down the line, the service fees that you can charge will go down. So you need to constantly find ways. But again, I like the idea to just say, me as a protocol, I maybe don't need to worry too much. I outsource it to sales team, and they can worry about that.
Right. So you've heard it from Robert. Yeah. Over time, actually, the cost of technology tends to go down, tends to go to zero. And essentially, we believe that most of the service fees are going to become smaller and smaller. And especially if they are charged for commodity services, they are going to go close to zero. So the importance out there is to come up with value-add services that are added on top of the typical infrastructure play. But yeah, we see already several projects out there doing this quite successfully. So yeah, with that being said, I would like to ask Robert, what do you think are some departing thoughts for you? So after studying together Pocket and also having some other networks in the pipeline, studying them in a similar fashion, what are some of your departing thoughts and some of your recommendations for protocols?
Yeah, I mean, if you're building, I mean, it's for sure, it sounds simple, but it's like, you know, the one-on-one is really focus on like scalability, efficiency early on. You know, if you're lucky, or like any DePIN likely has this like input of like early on token rewards, you can spend a lot to incentivize your supply side. But this is why it's important to really go into understanding your cost base, monitoring, understanding the biggest cost drivers. Sometimes it's obvious, right? Live peer switching from Ethereum to Arbitrum as settlement layer and reducing this cost by over 90%, fine, right? That's an easy call, but you really need to be ample on this one. But yeah, other than this, really think about leveraging other DePINs, think about the functions in your DePIN, and really think about, do I need to do it myself? Do I need to build myself? Or is there something out there that I can leverage or that I can even incentivize to do? But yeah, with this, I guess we're also out of time. Obviously, if you have more questions, you know, hit me up. I'm happy to help with any design questions or whatsoever. Yeah, the contacts are here. I'm not sure if you still have time for questions.
All right, one question.
Okay. Anybody else? Then Wook?
Why, Robert, you don't like the hard ones? So how are you thinking about token lock, burning, and in general, like, the role of the token holder that is actually like enabling these economies?
Can you speak up a bit?
Yeah. How are you thinking about the token holders that are actually enabling like all of these economies to be sustainable? How are you thinking about burn, lockup, balancing this out in order to not create coordination issues and so on?
Yeah, I mean, that's a good question, right? Like, where's the token holder fitting in? And here I'm coming back to the roles and the function that you want to have people to do. And they are very widespread, right? I mean, you can expect them to do governance. You can expect them to delegate to help securing the network. Maybe you just expect them to hold or provide liquidity. Again, you just need to be sure what you want to expect from them, because if you just want them to like be rarely passively hold and still benefit from doing so, which is a design decision, then a burn mechanism makes sense, because if you burn token, you're basically benefiting everybody, right? Because the supply goes down for everybody in the same fashion, right? However, this also means like, yeah, that means if you want to reward specifically stakers, if you want to reward specific actions, burning is probably not the best tool, because again, you're not rewarding a specific crowd, a specific user base, you're rewarding everybody in the same fashion. So yeah.
Great.
Yeah, I agree on the burning aspect, and I think for token holders, the best thing that they can do is to actually stake, and yeah, to have skin in the game, because when you're staking, you're actually not getting diluted by monetary inflation by essentially issuing tokens. So I think probably this is the best thing that they can do. They can start with, and then afterwards, yeah, being up there in the discussions, in the forums, and voting.
Excellent. Well, let's give a round of applause to Robert and Mihai. Thank you, guys. You guys leave the mics there. That's good. Can I get the clicker? This is what I need. Thank you. And I think that was actually a perfect transition, because they were talking about staking and token models. And so I'm going to discuss Fluence and give a little bit of background as to what Fluence is, but go into a lot of depth as to how we structure our token model. Because our token model, I think, is not typical, and it covers a lot of the key of the elements of design that Robert and Mihai spoke about. So, and the other good news for everybody is they ran over, which means I'm going to run a little shorter. So I hope everybody's very happy about that. So Fluence, cloudless compute, and we're going to talk about how we architect this sustainable network. Let's see if this works. So what is cloudless compute, first of all? What is true decentralized compute? It has to have two attributes, which is fault tolerance and verifiability. And so the Fluence network will be always on, global, and self-healing from downtime. And it's not controlled by any one entity. And there's a variety of definitions of decentralization and a spectrum of it potentially. But the key piece is understanding for us, decentralization, the critical piece is it's not controlled by any one entity or small number of entities. And whether it's 1,000 nodes or 1,000,000 nodes, the lack of control that anyone has is what really renders it decentralized. And so what's special about Fluence Cloudless? Well, it's real-time tolerance and failover built in. And that means your compute is provisioned to the network, and if the provider goes down, that compute is automatically re-provisioned to another provider. All right, that's very different when you have transparent, costless switching between providers. That allows you to create an actual cloud alternative. You also have verifiability and auditability of compute. So you can verify that compute was run on specific data. And that is necessary for a whole number of AI use cases, for regulatory and audit use cases as well. And low cost. This we think is about 80% cheaper than the cloud. And there was a question on Impossible Cloud's presentation about where low cost comes from. And so here it's worth spending a moment on this. Fluence is a CPU network currently. There are excess CPUs, not just in people's houses, but in top-tier data centers. These CPUs are sitting there unused, and so they are effectively sunk costs for those providers. They profit by just covering the cost of electricity to have those run. And so when you can offer a provider revenue for running their idle equipment, that they will take that at a far lower price than what they may charge a customer who will commit for a long period of time. And so, we are, another kind of message here is that the compute that Fluence runs is not a string of laptops in people's houses. Our first providers, I'm going to go into later, are 6 top-tier data centers that run FANG technology and FANG servers. And even those data centers have excess CPUs that people are looking to monetize. The other component here is that Fluence is serverless. The serverless offering is complex. Very few companies can offer it, and so Fluence can offer a product to these data centers they are unable to offer, that are accustomed to renting out a server for an extended period of time. Serverless, on-demand, entirely new product, entirely more complex to offer that they can't. And so those are a couple reasons why the cost and the price is far lower than centralized clouds. And so why cloudless? Well, it's also secure. There's no single point of failure. When you have a network that is operating with dozens of data centers or hundreds of data centers, there's no point of failure. When the network goes down and when a provider goes down and it re-provisions automatically, that is much more secure than one particular provider. It's distributed, we talked about that. There's censorship benefits to it for sure. Cheaper, we've talked about it. Verifiable also, and it's green. And this is an interesting point because there's certain data providers and data centers we have on the Fluence network that are only operating on sustainable energy. And so you can select, you want your compute to only run from renewable. And that is a criteria that you can use at Fluence that is not possible in traditional centralized clouds. We are attempting to move on. There we go. So benefits, and we've talked about a couple of these: verifiable, censorship resistant, and low cost. The last one is buildable. And this is really important, and this is a critical attribute of decentralization. But when you have compute running on a decentralized network, that module, that program is now out. No one controls that anymore. The author no longer has control. It's running out there. And as long as any customer wants to pay a host to run that program, to run that module, it will keep running. That means if you are using that module, you're not forced into upgrade cycles, and you can build on it with the security and comfort of knowing that won't change, it won't be decommissioned, it won't be taken away. And so the buildability, we think, is a terrific advantage of running decentralized. If you're running on a cloud stack, they may decide to change or alter any of the components on which you've built, which then leads to a number of tooling update requirements for your project, for your protocol, for your application. If you run decentralized and these applications can be hosted anywhere in the world by any provider, then you are not subject to that upgrade cycle. You're not subject to that risk. And you can actually build on and then that gets to the application layer. An application can run that way, which means that application can't be shut down, which means you can build on top of an application with the same certainty. And we haven't yet seen that. So what isn't cloudless? A marketplace isn't enough. And we see a lot of marketplaces out there. And you see compute marketplaces, but my browser is actually a marketplace. I can choose between Google and Amazon just on my browser, and that is, does not make it decentralized. You need to have resiliency, verifiability, and cloud services, or you are not cloudless. And so what also do you need? You have to have a stack. And so Fluence has built an analogy to the cloud stack with different software layers that allow the tooling and help the tooling necessary to actually run applications. And so you need to have all of these different components in order to serve applications and to serve customers. This list of services is just the beginning. We need a lot more tooling and a lot more services to really compete with the cloud, but this is the outline, the skeleton, which we will fill in to allow basically web scale applications to run on Fluence. And that's why we think the Fluence is the next generation of compute. And so you started off with mainframes and desktops, as everybody knows, and the next generation was AWS and the centralized cloud, Google Cloud, et cetera. That has been a huge development over time, and that has become an enormous business. But we think cloudless is the next iteration, and probably this decentralized cloud is the final iteration where applications can run completely decentralized. But how do you structure the token economics to make this work? And this is the hard bit, because you can create some of this technology, but you need to have the economics right in order to have the incentives and the security. So first, you want to attract long-term providers and reward consistent network participation. So when you are paid in tokens on the Fluence network, those tokens vest over 6 months. And so if you decommission and you take off your compute right away, you lose the rewards that you've earned. So right away, that incents people to keep their network and their compute online for a longer period of time. And that means every day it's online, they earn more rewards, and that's 6 months until those are fully vested, right? So once you're on, you have a real incentive, and hopefully a growing incentive, to stay online. And so you obviously will take some market volatility over that period of time, but ideally, token over long periods of time goes up, and the incentive to stay online only grows. And this is FLT, so that is kind of the vesting reward. Vesting of rewards is kind of point one. The next problem is a low token price, a high token price. You got to be careful, because if your token price goes down, your provider's costs are in fiat, and they will not have enough to cover their costs. That is a problem. And if they turn off, then your network goes down. And the high token price, this is something not thought about as much, but in a high token price scenario, they may not have interest in actually serving customers. They're too happy earning coins, and they don't actually care about customers. And we've seen this happen in multiple protocols, where in the real moon scenarios, they don't want to do the work with dealing with customers. And so you really don't want to have that happen. And what's our objective? We want a stable reward to attract utility providers, not just speculators counting on a high token price at some point. And so how do we do that? we calibrate the rewards in fiat, but pay in FLT. And so what that means is we calibrate a reward which is $10 per core per month. So it's roughly $600 per CPU per month. And so if the token price is 50 cents, as an example, that $600 reward would be 1,200 FLT. If FLT went up to $2, that $600 reward is now 300 FLT. So that recalibration, and it's not a minute by minute, that calibration happens a max of 10% a day, which is per epoch. So it always is going to trail, right? It's always going to trail. But that calibration helps mitigate the over-reward that some people may get, and also the under-reward, because we don't know where this price is going to be in a month or 6 months or a year. So it's kind of bizarre for us to arbitrarily set a crypto token reward when we have no idea what the market is, where Bitcoin is, the adoption of Fluence. It's really hard to do that. So, and how many providers will be on Fluence. So this recalibration, I think, is a really important piece to link things back to fiat. And there's also, and staking works the same way. And so staking is the same concept. Where to stake, it takes $12,000 per compute provider, $200 per core, again in FLT. So if FLT falls, you need to buy more FLT for the stake when you restake. If FLT goes up, you need less FLT to restake. So you stake to the compute provider does proof of capacity, and the reward goes back to the compute provider. Again, that 600 we spoke about earlier. And then the question becomes, how much does the investor get? And this is a marketplace delegation. We think it'll be between 5% and 40%, but the rewards are split every time an investor enters into a delegation agreement with a compute provider, that they determine what that split is up front. So the investor knows, I'm going to get 10% of the reward, 20% of the reward, 50% of the reward. That's determined upfront for as long as that compute contract is in line. And those compute contracts can go from 1 month to 2 years. And we expect to see a range of durations and delegation staking prices to fluctuate based on what those ranges are as well. And so the other part to think about here is, will people want the token or will people want stable coins? Because when there's useful work, the providers earn stable coins and they do not earn FLT. And we clearly want to incentivize useful work, people to be paid in stable coins, and for the network to generate substantial use. And so some compute providers probably will want FLT, some will want the stablecoin payments. Stablecoin payments, no vesting, right? So they may charge less than what they would receive in FLT. But some providers may want the FLT, so they may charge more because they think FLT is going to go up. So they actually will charge more than what they would receive in FLT because they're really bullish on FLT. Others may be more traditional Web 2 data centers and be like, you know what? I really don't want FLT. If FLT is $10 in FLT and invest over 6 months, I'll sell compute for $8 because I can get that stablecoin today with no vesting. And so we expect there, and other people like $10 FLT, I think it's going to 20. I'm going to charge 14 for compute, right? That's what makes a marketplace. And so we expect to see a range of pricing based on people's interest in receiving FLT and their comfort with the vesting schedule. So what's the scale of FLT staking? And again, this is interesting because it goes back to the USD value. And so our goal this summer is to have about 1,000 CPUs, 64-core CPUs. That requires about 12 million of FLT stake. And by next summer, our goal is to have about 50,000 CPUs. That would require $600 million of FLT stake in order for that to actually be operational and running rewards. And that 50,000 CPUs is a big number, but we're not talking GPUs here. These are CPUs, and there are billions of them in the world, and that's about the size of one Amazon data center. And they're individual providers we're talking to, multiple of which are able to partner with us to deliver that amount of CPUs to the network. So that is our goal, and that's our objective to get to that. And that just gives you a sense of scale that we think is out there and is what the potential could be in the sort of next 12 to 18 months. Who are we partnered with? So we partnered with top-tier data centers. These are people I mentioned before, and this is a real, I think, important element of DePIN to focus on. When people think of DePIN and think of crowdsourced infrastructure, they think of retail infrastructure, they think of laptops and home computers. But every mining and every single type of Web3 infrastructure has started off with home hardware and has migrated to institutional hardware faster and faster and faster. Bitcoin miners started off at home in basements. They are now publicly traded companies with multi-billion-dollar market caps running, massive data centers. We've seen it with Filecoin. Started off with people storing in their homes, and that quickly moved to purpose-built data centers for storage, right? And so we're shortcutting that immediately by starting with some of the top data centers and data center infrastructure in the world from day one. We are also enabling retail storage, and I think we'll see retail storage compute as well. But our focus is, and what we think customers really want, are institutional quality data centers running very reliable compute around the world. And that has been our kind of a knowledge and focus from the beginning. These groups here have about 4,000 servers that they can commit to us. 200,000 cores, and that's just the early bit. I think this group actually could be probably 10,000 servers. We just haven't gotten there yet, and we're sort of slowly ramping up the capacity on Fluence. Couple quick points. Fluence is governed by a DAO. We governed it from a DAO from the beginning. We set up the DAO in February. Actually, set up the DAO in December. Had a token generation event in February, and the token started trading in March. So that is what governs the DAO. So on-chain voting governs almost everything with regard to Fluence from the very beginning, from the first day of network launch. And how big can this be? We think about how open platforms capture value. Right, Ethereum, this value is a little bit dated given the last week's news and given some of the ETF news. So I think we're significantly above that given where things have moved, which is terrific. But we think of Fluence as an open alternative to the cloud, and that is just a vast market. We will not capture all of it. We'll capture some piece of it, but it is vast. And so us, with a variety of the speakers here, are excited to attack that market and take pieces of it. And if you have the right token economics, I think you have a real potential to create a lot of value. And so want to thank our investors, including 1KX, who are here obviously in sponsoring this, in giving us the capital to attack this very important market and to help free the world from the oligopolist clouds. I think we all need, if we do not beat the clouds and we do not have an open alternative to the clouds, we are going to live in a very different world, which is, I think, none of us will enjoy. So whether it's Fluence or whether it's another decentralized compute provider, compute is the last piece left to decentralize, and if we don't do it, we're all running on Amazon, we're all running on Google, and that is a very, very disappointing world that I don't think anyone here is excited about. So please help Fluence, help other decentralized compute providers by any type of participation, because this group is the one that is going to help us basically keep us all free. So thank you for your time, and appreciate your attention. And I am right on time. So any questions? I get to MC my own questions. Yes. There's who has another mic? No, we'll just alternate.
Yes, so my question is, do you expect a large fluctuation in the compute capacity with the partners that you work?
It's an interesting question. The way we think about that is we want to have always excess capacity that's about between 20 and 30% beyond what we are currently serving so that we can handle should some providers go offline or shut down. So I don't think we expect lots of fluctuation in that capacity. I kind of think once people put it on, they'll keep it on for a while. It will happen. People will deactivate, but our model is set up to keep it growing and to keep it online. But life happens, customers happen, all management changes. Like, of course it will fluctuate, but I don't think it will fluctuate dramatically. And our objective is to build up a scale that we can handle that deactivation with no impact on the network. Actually, I'll just repeat the question. If you ask, I'll repeat it. Well, the question is on the green energy provider. So one of our providers operates exclusively from hydro, and so that's all their data centers, all their electricity comes from hydro, and so they are one of our early partners, and that was an important and basically a cost savings to them, and also an important ecological kind of point for them to do it. We're excited to partner with them, but the cost there is not different than others, and we are just happy to have that as an attribute for others, for our compute customers to be able to use. Does that answer it? Yeah, oh yeah. If you choose, you could choose 100% green, and then it would go right now to that provider. And so you can literally choose that either it is right now or it will shortly be one of the criteria you choose when you want your compute to be provisioned. You select maximum price, redundancies, potentially location, and then green is another one, and those criteria have to map. So if you were to choose, for example, you want 5 failovers, but you want to be in Europe, well, unfortunately, that data center is not in Europe, so you're not going to work, right? So you have to select the criteria, at least right now, where they all match. But yes, that is an option. All right. No. Oh, yes. Question. Sorry, couldn't see it. Pillar.
Right now, there are like H100s for compute, and when there's a new generation coming of faster compute, how do you mitigate the risk of people that actually supply the compute to Fluence to not only be able to buy Fluence to keep the stake up high enough, should there be downward pressure from having to cover costs, but also still being able to buy this new generation of compute to supply the necessary capabilities. Like, how is that mitigated with the tokenomics?
I'm not 100% sure I grasp that, because listen, there may be times when people, in fact, we're in discussions right now with a group that wants to monetize new hardware based on Fluence. And so that's happening. Our objective is to use excess compute, the bulk of it be excess sunk cost compute where people are not actually buying it. The other point here is you're thinking of the reward cycle, right? And that's terrific, but at any level approaching maturity, almost all the revenue that compute providers receive will be coming from actual compute jobs, not an FLT token, right? So if you have compute on the network, our objective, and this was mentioned earlier, we're launching a sales team. We want these compute to be used by real providers, which means you're not getting paid in FLT, you're getting paid in the stablecoin. And so the stablecoin for us, in FLT, our FLT rewards are basically a bootstrap period until there is sufficient demand of real customers providing who are using this compute. And when that happens, then you no longer have that sell pressure on the token to cover costs because people are receiving stablecoin instead. And so this is just the FLT reward is that bootstrapping period. Okay, I am done. So thank you all, and we have a panel coming up. So stay in your seats for this panel. Where are the panelists? Come on up. I'm back to my MC role here. Who's coming up? Panel, hello. We need John. Where is John? On stage. Joel, let's go. There we go. John gets points for his note card formatting for sure. And everybody's got mics. Good.
Testing.
Good.
On yet?
All right.
You can hear me? Good afternoon, and welcome to the first panel of the day. I think the discussion amongst the four panelists will be a little bit different as they each represent a project or organization that is not as traditionally related to DePIN in some cases. So that will be one of the central themes of the panel today. I'm going to introduce each panelist, and then they're going to give you a quick 1-minute spiel on their project or their company and why they're here today. So to my right, I have Paxi, who is the Chief Strategy Officer of Stacks. Next, we have RG, founder and CEO of Repo. And then we have Joel Thorstenson, representing both 3Box Labs and Ceramic. And finally, Matthew Fontana, head of ecosystem of Streamer. So thank you all for joining us today here in Berlin. And Paxi, I'll start with you. Tell us a little bit about Stacks.
Thanks, John. I'll give you an example. Yesterday, we had more than 100 people gather, and part of our partners, if you're interested in actual applied industry blockchain Web3 tools usage, we're working with Vantage Towers that operate 84,000 telco towers. We're working with Rewe Group, the beloved Rewe Group. I'm sure you do groceries. We're working with their payment tools. And so we're building large projects based on Web3 tools, but for industry. And I'm all about market adoption, so I invite you all to talk to me if you have, ingenious Web3 tools for us to play with. Thank you.
Thank you, Paxi. Hand it over to you, RG.
Thanks, John. So I'm RG, I'm the co-founder and CEO of Repo. Repo is a risk and reputation modeling network. So we started out with solving DePIN verification, which was, Tom mentioned this in his talk earlier, but really the challenge of understanding the behavior of different nodes. Our thesis is that if you're able to understand the behavior of nodes on a network, you're able to claim that you have a metric for the quality of the network. So that's really what we're trying to do. For us, the vision is a bit broad. DePINs is our first go-to-market, but we're kind of focusing on risk and reputation broadly in the world, thinking about AI systems. So as the Repo protocol, we're in the incentive layer that is incentivizing people and world to think about risk and reputation in our decisions that we make on a daily basis.
Thank you, RG. We'll move on to Joel.
Hello. So the project I'm working on is called Ceramic. It's a decentralized data network. And one of the main things it enables is you to create these mutable objects that are version controlled. They're tamper resistant, cryptographically signed, and are sort of independently verifiable. And what that means is essentially we can have a lot of these objects in a global namespace without having to have global consensus over everything that's going on. And everything is sort of still shared over a peer-to-peer network.
Thanks, Joel. And finally, Matthew, tell us a little bit about Streamer.
Streamer is a peer-to-peer decentralized data streaming protocol. So you can stream any kind of data to any number of subscribers, all in real time, all through this peer-to-peer mesh created by the users and devices of the network. So it is useful for DePIN projects especially, and AI, as well as live media streaming as well. So those are the three verticals that we're really targeting.
Great. Thanks all four of you for introducing what you're working on. We're going to launch into about 9 or 10 questions, some group questions and some individual ones. However, if anybody in the audience thinks of a question while we're up here, don't hesitate to raise your hand, and we'll give you a chance to ask any of the four of them something that's on your mind. So I'm going to start with Matthew. Tom launched the DePIN Day Berlin this morning by giving his definition of DePIN, which is not even a year old or so, as an acronym for what we're working on. But Matthew, to you and Streamer, what's DePIN, and how is it distinguishing itself within the Web3 marketplace?
Yeah, I think that DePIN is, it's been said before that it's a new name on an old thing, kind of, and that's fine. But
what's the old thing?
Old thing is kind of all crypto projects have these same themes and actors, and there's a token, and there's some sort of coordination, and so on and so on. But what probably differentiates DePIN projects is the role of the community and the active nature of the sort of workers in the system. So there are all sorts of different projects that have communities. And those communities are very important to those projects, but with DePIN, the community is the infrastructure, it is the project. So they live and die off that active role of the contributor. So, yeah.
And in the case of Streamer, how would you clarify participation and incentivization? I mean, could someone in the audience here just randomly start participating in the Streamer network and be incentivized?
Yeah, they can join the network. It's decentralized. You can, it's totally trustless, and you can kind of use it for your own needs, and it works off the principle of reciprocity. But where the incentive layer comes in is that you have the ability to sponsor infrastructure to join. So kind of like hiring a backbone to your network. And so if you want to participate in that kind of process, then you will need to kind of run a node, and that relay node has the promise of staking tokens and basically promising that they will be open and online and kind of do honest good work. And so, yeah, similar process in most crypto projects. You do your job well, you get the carrot, and if you do it wrongly, you get the stick. So, yeah, that's how it works at Streamer.
And carrots or sticks working better for Streamer?
Carrots are good for everybody. Yeah, we don't like to use the stick.
Fair enough. Thanks, Matthew. I'm going to move over to Joel, who again is working on the project Ceramic. Joel, why should builders and developers use these DePIN solutions versus building it themselves, using a status quo Web 2 project or something else? Why, and what are some of the reasons? Minimizing risk? Is it just about incentivization?
Yeah, so I guess on using DePIN in general, to me it seems like there's two different things that you would want to do that. One is this cheaper and better? Which might be the case for some DePIN networks. Some DePIN networks might not be the case. I think there's probably a spectrum. I think the other reason is that you want your users to have more sovereignty, either if that's from an ideological perspective, or if that's actually a requirement for your application. And I think that the third thing of a requirement for your application is probably the reason why many are here and why all this is super interesting.
Understood. So participation can make it cheaper, better, faster for some individual developers.
Well, I mean, I think in some cases the DePIN network might have been constructed so that in certain use cases it's cheaper and better. But I think in some cases the DePIN network might actually be slower than a Web 2 alternative, but still provide other types of benefits when it comes to like the sovereignty of the users interacting with the protocol, such that like that might actually be a requirement for an application to function at all. And so there's probably like between those things, like different developers might select different reasons for why they need to use DePINs.
RG wants to jump in.
I think it's also important for us to not only look at like end users, which are like, you know, just like people who are using the 5G or using the solar and the developers. I think using the supply side as the users is important here. And the reason I say that is, you know, when we look at a network like Fluence, right, they're trying to bring like unused hardware that is kind of just like staying, like, you know, is currently latent to the network. So the supply side is also a user in this case. And the second thing is these are new markets. So what we're seeing, especially with things like Filecoin, is there's a company called specs.website, which is enabling a brand new secondary market for people to trade miner IDs. And so if it's worth anything, you know, like at least the finance people are coming in and bringing liquidity. So it's a product for them, and it's a brand new market. And I think it's important to acknowledge that, you know, as of course we want to like replace current systems and, you know, disrupt current systems. But I think just expanding our thinking about who the users are, I think is helpful as we like wrap our heads around DePINs.
Can you actually give me an example, like the best example that you guys have, where like a participant that contribute really is benefiting from these networks? Like what would in the world be the best example of this?
Like someone who's contributing and benefiting?
Yeah.
Like I can tell you, like, you know, I was at Filecoin for 2.5 years, and the early people who joined the Filecoin like network as storage providers, some of them have done really, really well for themselves. And they have gone on to, you know, build businesses supporting other networks beyond storage. And so I think I would...
Later on as well, like the whole network benefits, not just the top?
Yeah, because definitely the whole network benefits, because I think what you have right now is, well, Filecoin is moving, I'm just using the Filecoin as an example, like Filecoin is moving now to FVM. Like for all those things to happen on Filecoin, you needed, you know, for the initial players to come in. And so I think that, yeah, so, you know, I wouldn't just say that the users of Filecoin are only the people storing the data and the developers building using FVM. I think the users of Filecoin are also the storage providers who mine block rewards, right? So I think it's really important to acknowledge that.
No, I'm glad you brought that up, because, you know, attached to this question is, do we all care about a fair distribution of economic rents? So maybe some people in the audience think more about macroeconomics rather than the technology. I'm one of them. And I think one of the benefits of DePIN is the possibility to have a fair distribution of economic rents, rather than just Visa or Facebook, Meta, Google taking the lion's share of the economic rent that flows through a centralized system. Here we all have a chance to change it, right? And my 2 cents, though, hearing what they were talking about is, I heard early contributors to Filecoin did well. Early contributors to the Helium network did phenomenal. But after a year or two, they didn't do so well.
That's
so
my
I think
point.
the DePIN industry faces this challenge. How can you, for instance, create a token economic design that fairly distributes over time, not just to the early contributors who maybe have insider information, got their hands on the first device, et cetera, right?
So guys, I totally believe you contribute, you need to be compensated, right? At whatever level. We go about it slightly differently. We would like to work with corporations, build a network for them, and then invite, for example, yesterday we launched a drone. We work with German drones. We were connecting with the machine. Right now we still use a payment tool that uses real euros. Next step would be tokenization, but hear me out. Connect with the machine, whatever task that drone needs to perform. For example, I need data over this certain location, right? You have a drone, you can fire up your drone, land a drone, get paid, right? Landing fee, takeoff fee, data, storage fee on a blockchain, all that good stuff. But if we don't have industry and government embrace some of the stuff we're doing, it's going to stay with, you know, a few good guys trying to have this, I don't know, vision of the world, and in the end it falls flat. So I would really like to drive forward this, like let's I don't want to kumbaya, but let's join hands. And because
Oh,
that's what
that's
the
fine,
community is about, right? In the end, we want this community. So we have expertise, but you guys have expertise. Can we find a way, especially while we're in Berlin, to do some of this stuff together? Because once we have this network for industries, we can invite anyone to come on that network and say, okay, what can you do well, and what is your contribution, and how do we then compensate you?
So Paxi has actually just answered the question I was going to ask her, which was,
'Cause I'm so passionate about
why
it.
do system builders and dApp developers need DePIN ecosystems? So maybe I'll change it a little bit. So I think you just stated that Stacks itself is not building out a DePIN, but wants to offer its services and systems to others that wish to. So
Right.
besides the drones, can you give us another example of an institution, whether it be regulatory or a for-profit company, that Stacks has provided the infrastructure for a DePIN and how it's gone?
So right now we're working with Vantage Towers, as I mentioned. So they would like to collect weather data, sell weather data. They'd like to do electromagnetic fields around their towers. Because as you can imagine, guys, all these telco towers are super expensive in maintaining, right? They need to do reporting to the EU. And we don't want a situation like Volkswagen where people can go in and change these values. So they are looking into Web3 tools. How can Web3 tools make us money or save us money on these really expensive land that we own, on these expensive towers we need to maintain? The more we can help industry and governments, right, in, yes, making money, the more they will embrace it, the more they will have opportunities to then, I call it, I know people don't like to hear this, Web 2.5, because there's still Euro involved, but then we slowly can move towards tokenization. And then I think the community can benefit, because if you're part of the network, you can write some smart, whatever, dApps or whatever, and say, hey, guys, I made this, can you use this? And this is maybe not for everybody, but it's truly what we need. Look, we had the Staatssekretär Wirtschaft, Energie und Betriebe yesterday at our event. They are willing to listen, but let's work together.
That's a step in the right direction. I'm not sure all regulatory bodies are so willing to listen to those who are advocating for decentralization. But I think all of us are starting to see it slowly change, right? All right, RG, sorry. Talk a little bit about the challenges that data exchanges and connectivity layers such as Repo are facing. And dual part second question is, what are you bullish about with Repo? And do you all like to say trust or trustless in your system description?
Yeah, that's a good question. I'll try to tackle the second one first. So I think kind of, what we just said. I think a big component about scaling like DePIN networks or crypto networks in general is helping folks outside this room really understand risk and reputation, because that's what it comes down to, right? A policymaker wants to know, Gary Gensler wants to know, like, what is the risk and how is this going to impact, someone's reputation? And I think this idea, a lot of the times people mix up this notion of trustlessness and with like getting rid of subjectivity and trying to be objective. And I think at Repo, we don't believe in that. We think that the idea of trustlessness is very different from the idea of being objective. Because at the end of the day, if you're operating in this world, if you're living into society, you are inherently subjective. And I think we need to build systems like Repo, which, just to give you an example, so Repo is building like a network. So the best way to think about it is an incentivized layer like Hugging Face, but specifically focused on risk and reputation models. And we actually have a data exchange within Repo. So the way the data exchange works is if anyone in this room today wants to build a small model, we're not talking about LLMs, we're talking about small, like you can talk about like small language models or small models which are specifically designed to do one thing. So let's say you want to know the behavior of Filecoin nodes in Germany. That's the only thing you're interested in, because you're working with constraints that were mentioned, that people want to store data within Germany, regulatory reasons. So now you are trying to understand who are the best nodes of Filecoin within Germany. There is a model that someone will build. So now to build this model, you need data and data sets. The data is needed to guide your heuristics, and the data set is needed to, of course, train the model. And so the data exchange that we're building is, think of it like an order book. If you're a modeler, you should be able to come to repo, order the data that you want, put a bid, and then basically get the data. And for us, that's how we think about trustlessness. Trustlessness.
So that's where you go to trustlessness.
Yeah.
You don't want participants or users to trust.
No, I think there is a very close connection between trustlessness and verifiability. And I think what we have seen so far is that we just...
So which is it? Is it verifying?
Yeah.
Or is it trustlessness?
I think it's verifiability plus subjectivity is equal to trustlessness. I think what we've done so far is we've just said, hey, all the transactions are on chain, so it's trustless. That's not true, right? Like the average person in this room isn't going to go and query the chain to prove it's trustless. I think what you need is like an intermediary, a consumable metric, so to say, that you can take to a policymaker, you can take to a client, you can take to a storage provider and say, hey, this is what it is, and it's verifiable. And I think that's what we really think about.
Got it. All right. For this next question, for all four of you, a raise of your hand is all that's required. Are all of you using blockchain or some other type of decentralized technology? I think that's
I even have crypto.
4 for 4 there on using blockchain. But there are a lot of projects that use different types of decentralized technology, right? So an easy one. Okay, Matthew, back to you. Multiple choice question, or you could weave in the answers. Where do DePINs provide the most value? Intra-network exchange, financial incentivization of participants, providing trustless systems, or maybe is it for the speculators in the audience who are really curious about the value of the token incentivization of your network?
I think it depends on who you ask.
Well, I'm asking you, I suppose, and by you, streamer.
Well, I guess with my streamer hat on, I would say that actually it's the financial incentives. And why I say that is that perhaps from kind of my personal beliefs coming through here, that if you can put a pipeline directly from the workers to the incentives, that is the big win, removing those middlemen. If we can accomplish this through decentralized technologies that handle the coordination and the operation of the network and kind of export value, while at the same time we kind of have that very direct, simple path of incentives to work, then we
understood.
Win. Yep.
And I would say of the 4 projects on stage, yours is by far the most mature.
Absolutely.
How many nodes run the streamer network today?
There are, I think, maybe 1 to 2,000-ish. Now, we used to have...
It's a big spread, 1 to 2,000.
Well, it's a decentralized network, and decentralized networks are actually very difficult to observe.
Sure, so some are on and some are off. Yeah, okay.
If you get a very sharp answer, you know they're kind of fluffing. Yeah, we have like quite a large network. It used to be actually much larger when it was actually semi-centralized, and what we found was that when we made it more efficient, and perhaps going back to the earlier talk about Pocket Network, they noticed that drop in nodes, and that was actually from an efficiency improvement. So sometimes bigger is not always better.
Yep.
And if the nodes are kind of doing their job well, then you may need less of them.
No, thanks for the answer. And just as a kind of wrap up to my question, I can participate in Streamer?
Yes, you can.
Great, and because this is going to lead into my question to Joel, how much do I have to pay out of pocket for the hardware node to participate in Streamer? What's the cost to me?
If you have a Raspberry Pi or even your laptop, you can run the node on that. Otherwise, you can do what a lot do and kind of use cloud providers to, and that's a few dollars a month, and APYs at the moment are about 40 to 50%. So it's
fair enough. And
easy.
The average node operator grosses how many euros per month?
Depends on how much they stake on the sponsorship. So it works based on that relationship. So
Okay.
if you have a lot of euros, then you'll get a lot of euros, and that's.
So fair enough. So for all of you who have an extra 300 euros, apparently you can go get a Raspberry Pi set up and start a node on Streamer. And you can calculate your return on investment by figuring out how many tokens you want to stake in, right?
Come see me and I'll tell you how many.
Or come talk to Matthew after the talk, great. So Joel, how has the incentivization models worked so far? I understand what you're working on is brand new and has not yet launched an incentivization model. So maybe the question is, what do you all plan to do? What type of model is Ceramic going to introduce to the world for someone like me or someone in the audience to join?
Right, so well, to the question in general, like what types of incentivization models have worked, I think like the ones we really know are working is just like blockchains that are producing blocks and sort of the applications on top of that. I think it's interesting that like that's pretty narrow, and like the types of things that people have been dreaming up is like extremely wide. And so, and it would be interesting to see like in a couple of years when we see some of these like mechanisms becoming more mature. As for ceramic specifically, we sort of think of it in a few different ways. So one thing is that we don't want to create like a monolithic network where you come and like there's only one way to run a node. We actually want, sure, there to be some incentive for people to run node and host public data in the network, but we also want the ability for like end users to run nodes that even like run locally in their browser or on their computer, so that they don't have to like necessarily reveal all their data that they're creating, and then maybe be able to like selectively disclose that data to other people. So that's sort of the end goal that we are shooting for. So we don't want to incentivize all of the data, because if someone is incentivized to sort of make your private data public, that wouldn't be very nice.
Yeah, fair enough. So it sounds like a possible two-pronged approach where investing in some hardware and joining the network could be incentivized, but also picking and choosing what data is going through your node to expose to the network could be a second way to incentivize.
Yeah, I think that mode of like selecting what data is on your node, or you as a data producer selecting which nodes have access to your data. On a different perspective, like one thing that I think is interesting about Ceramic is that you have end users producing data that is cryptographically signed by keys that users control. And so one thing that we think about being useful, not necessarily for Ceramic as a network directly, but for people building applications and then just like leveraging data that exists on the network, they can look at the network and a bunch, like graph of contributions of users, and potentially use that data as a way to reward their users.
Yeah, thank you. All right, one last question for the panelists, and I think we're going to wrap it up here. So this is a bit of a softball, as we like to say in America. I'll translate that for the German audience. That means it's an easy question. That's all right. What is your favorite DePIN project outside of your own? And I'll start. Mine is called Bitcoin. You might have heard of it. I think there's a very strong argument it's the original and most successful DePIN, but up for argument. But Paxi, yourself.
And it's truly decentralized.
Bitcoin?
Yes.
100%.
Exactly. Compared to many others, right?
Agreed.
We, like I said, are agnostic.
One answer. What's your favorite DePIN?
Chirp Wireless.
Okay. RG?
For me, it's going to be Prime Intellect. Yeah, it's an intelligence network.
Prime Intellect. Okay. Joel?
I'm going to have to go with the classic BitTorrent. Not the new thing with the token, but like the network that people are actually using.
The original BitTorrent, where you got all your music and movies from back in the
I only
2000s.
download Linux ISOs.
Fair enough. And finally, Matthew.
Demo, yeah.
Demo.
Special place in my heart because they actually started as a grant from Streamer, so yeah.
Yeah, fantastic.
Yeah.
So thanks to all our panelists for joining. Thanks to DePIN Day Berlin and Fluence for having us up here.
Great.
Thanks, John.
Thank you, guys. It's now lunchtime, so we have
lunchtime.
Half an hour for lunch. So eat quickly and meet us back here in half an hour.
Nice to meet you. I'll be around the rest of the day. So. Good? That's true.
This is going to be a challenge. Where is Slava? Slava, I think get ready because we're going to launch into this in a second. All right, guys, you hear the music. It's all starting. Move away from the bar. All right. Now, Slava is one of our sponsors. If you don't pay attention, your food and drink is going to disappear immediately. All right, all right, all right. Let's get going. Lunch was longer than we planned. You guys are eating more than we thought. Let's get going. All right. Let's get Slava on stage and get him talking. Maybe that's going to clear this up, and I'm going to run around and start knocking heads. Go for it, Slava. And then we have a panel. So, listen, we're welcoming Slava from DRPC, one of our sponsors. I'm going to ask people to calm down now. Hold on.
1, 2, 3. Okay. Guys. So, hello, guys. I know that you're have fun eating, but would be nice if you can listen to me a little bit. So, yeah. So today we are on decentralized physical infrastructure conference. So I want to talk to you about this topic, like how do we distribute work in a fair way between our protocol participants? Because I'm thinking about it a lot lately, and that's been a problem for us. So I just wanted to share a few thoughts with you, and I hope there's some people who also building some other decentralized physical infrastructure projects. Maybe you will have some insights, or maybe you will have some objections, and we have some discussions afterwards. So just to say, my name is Slava, as mentioned. I'm CTO at drpc.org, and we're building decentralized RPC infrastructure for the multi-chain future. So just a few facts on like what is gRPC basically. I hope most of you, or at least some of you, heard about RPC. RPC is basically blockchain API, and we provide access to the blockchain data. But we do it in a different way from some of our centralized competitors, like maybe Alchemy or Infura. We do it just in a decentralized way, meaning that we have a permissionless pool of providers, as on the slide, and we also own centralized gateway. Basically, the job of this gateway is to distribute work between those providers. So we have this like kind of situation where we have a request from user, and we need to choose who's gonna perform it. But we, like as my topic suggests, we need to do it fair. Like let's think about what is fair, and like how do we even define it in this context. So let's start simple. I would say that fair is to distribute this across, like you should only send it to people who, or providers, protocol participants who can perform it, right? I know it's obvious and probably like can think about it themselves, but despite the fact that it's obvious, it's not necessarily simple. For example, in the decentralized RPC context, I think we are the only ones who can kind of do it, and even for us, it's a challenge. The reason is like there's a lot of different stuff, like data providers for RPC are built different. They support different blockchains, they set up the infrastructure in different locations, on different hardware, running different blockchain clients with different settings. So when you have a request, it's a really hard task to tell like whether this or that provider can perform it. But let's imagine we can do that. So then we can just do, uniformly, randomly sample one provider from the list of those who can perform the request and just, spread it equally. It's kind of, a little bit of communism out there. But so the protocol participants are really happy. If you have enough requests in your protocol, they all have their equal share of requests, and they're happy. But the clients, as like end users in communism, often, and in this case also, not really happy. And the reason is because latency is very bad. Because sometimes, for example, it's not cool when you have a request originated in Europe and you send it somewhere in Singapore, right? It's bad, latency bad, users unhappy. So let's optimize latency, yeah? It's easy. Our pipeline becomes a little bit more complicated. First, let's assume we can predict latency. So we have this request, and we have a pool of providers. And for each provider, we can say like what is expected latency for each provider will be. It may seem hard, but latency actually is just like the weather. You know, the best prediction of the weather is that the weather tomorrow will be the same as today. Same thing with latency. If you try to send request to the similar request to this provider and measure the latency, you kind of can predict that most of the times the latency will be the same. So, okay, we predicted the latency, and now we use softmax. For those who don't know what softmax is, it's very high function in AI. Everyone uses it, like neural networks, stuff like that. Basically, you can throw a bunch of numbers into this function, and get a probability distribution, where each latency, or in our case, basically provider, will be assigned a probability of getting this request. So we got this distribution, and then we do weighted random sampling. Why that? Why we even do that complicated? You know, why weighted random? Couldn't we just, you know, predict latency for each provider, take the best one, and just send everything to them? Well, you know, we want to prevent winner-takes-all situation, because otherwise we will be too much dependent on the small subset, or like even one provider. And also we want to distribute the load smoothly, because RPC is actually like, there's a lot of requests, and request spikes cause problems. So we want to, if the provider's latency change slightly, we want to only slightly change their request distribution, not radically. Okay, so imagine we did it, and now latency is down, and our clients are happy. But now protocol participants are crying. What happened? Well, it appears that we can like classify our protocol participants as like in two categories. Like, for example, let's call them Charlie and Alice. And Charlie, he just rented the cheapest server, or bought the cheapest server close to a gateway. Remember, we in the RPC run centralized gateway. So it appears that latency, 90% of it, is actually about location, not your hardware. So it doesn't matter what you're running. If you're closer, you get better latency. So Alice, on the other hand, she spent like years into investing into her infrastructure, perfecting reliability and costs. But because of that, she can't move her infrastructure closer to the gateway on the moment notice. So she is in a big disadvantage compared to Charlie. So that's what I like to call latency arbitrage. Is it fair? You could say, okay, Alice just lost, you know? Charlie is more adaptable. He just, you know, optimized better for our protocol, so he should win. And also, users get smaller latency, they are happy. Why should we care? Maybe we should embrace Charlies of the world. Well, the problem is that our incentives, they are set up in a way that benefits non-reliable participants. So they can spend more time optimizing latency and less time thinking about reliability. But the clients that you work with, and you can imagine a protocol where there's 100% of the participants are non-reliable. So, for example, you can have like 50% of the time, most of the time, 50% of the protocol participants are down. But who cares if other 50% can actually serve the requests you have? Well, yes, but users expect you to function like your clients, not only generally, but you know, if you have, for example, some catastrophic event, or you know, just randomly 90% of your protocol participants go down, clients start to care because you have like few hours downtime. And you have those protocol where participants are not incentivized to be reliable. So the recovery time will be huge. and you pushed out everyone who cared about reliability because they can't wait for those catastrophic events. You know, they need to earn money all the time because they pay for their infrastructure. So it's kind of not desirable outcome. Also, you can argue that it incentivizes providers or participants basically buy or rent servers in the same data center as your gateway, which is of course not desirable because like if this data center goes down, whole region of your service can go down. So optimizing certain metric is really unpredictable. Like, for example, in this case, that what happened in DRPC for some time, I actually wasn't, like, I didn't think that it will play out that way. So you should have try to think about whole picture all the time. For example, you should have a metric on decentralization, and you shouldn't invent your own. Economists of the world, they spend really a lot of time thinking about this stuff. For example, there's a famous Gini coefficient, but it's a little bit hard to compute. So we used Herfindahl-Hirschman index. It's kind of an index of a monopoly on a certain market. So you can actually measure and understand, is your protocol basically dominated by one, like it's a monopoly, it's dominated by few players, or it's really decentralized. It allows you to catch those moments when someone gains maybe an unfair advantage and tries to game the protocol. So, yeah, reliability is important, you know, for clients. So, we kind of had some notion of reliability before, you know, because we said we only send requests to those who can perform them. It means that they should be up and they should be available. But it's kind of instant reliability. It means that we do not care if they were down 2 minutes ago. And maybe we should if we want to prevent those, you know, catastrophic events and have fast recovery. So let's say we can average error rate and uptime and have this metric of long-term reliability that we calculate, for example, on the weekly basis or month basis, depending on your needs. So then we can update our sampling formula, and it can look like that. We don't softmax only latencies, we now softmax reliability. Reliability and latency are vectors, and there's a coefficient that express importance of those properties for our protocol. So I think that this situation is a little bit more fair. Like, we now see that Alice is significantly more reliable. It has better reliability than Charlie, and we can send more requests towards her, and we now are incentivizing reliable behavior, which is great. But also, what about costs? Remember, Alice, you know, she spent a lot of time optimizing her costs. You know, they say that market is often fair, and you probably should have, if you build in decentralized infrastructure, you probably should have some kind of pricing auction built inside. It allows for better, efficient price discovery, give participants with optimized costs a way to compete, yada, yada. And you can also update your formula to be a little bit more complicated, but account for costs also. So this picture, like, you know, in my opinion, becomes even more fair. But who am I to judge, you know? Remember, we started, like, my arguments that we need to add this is basically because, like, clients need reliability. But why is it fair? Well, in my opinion, the only notion of fairness, actually, in this setting is, like, quality of service. So it's maybe obvious for a lot of you, but I don't know, wasn't obvious for me. So the only measure of fairness is whether you can have a product market fit, you know, because if your protocol dies, nobody cares about how well participants are doing. Like, you will be outcompeted. So I think, like, you need to optimize for quality of service, and this is the only fairness we get. In RPC setting, the quality of service is measured by 3 things, like latency, reliability, and cost. That's it. But what to do with those parameters? Like, how to determine which is more important for us, reliability or, I don't know, latencies? You can do some reasonable defaults. You can even vote if you want, ask participants what they think. But ultimately, the best one is if you can allow users to configure them. For example, if you're building arbitrage bot, you only care about latency most of the time, and reliability, of course. But if you're building some, developer tool, you don't care about anything, just about cost. If you're, I don't know, build some monitoring or stuff like that. So if you could just, configure it in somewhere in UI or in some library settings, would be cool. So the user is actually the ultimate judge of fairness, I would say. But there's one caveat. Despite the fact that you all, I bet, build your own decentralized physical infrastructure projects, the thing is that almost always there's some centralized part of it. For example, for DRPC, it's centralized gateway. So sometimes, for example, it may be tempting to optimize those metrics I said before using this centralized component somehow. For example, using caching for on centralized gateway. And it actually optimizes latency, cost, availability, a lot of stuff. However, the problem that if you do that, who gets the money for this request? The only reasonable answer would be like entity that runs centralized part of it, or the protocol itself. But in that situation, the problem is that you start competing with the protocol. So Alice and Charlie, they can play games and try to outcompete each other. But if you compare them to the centralized parts of this protocol, it's not fair. It's never fair. So they don't stand any chance. So the only thing that we can stay fair is basically you should never compete with your protocol, especially if you have centralized parts in it. Because otherwise you will be incentivized to take more and more and more, and where does it stop? On the contrary, if you only take a share of what protocol's earning, for example, like a DAO or something like that, you will do everything in your ability to increase the profit of the protocol overall, and you won't be competing with your participants. So I think we should remember about that. If you want to know more about how we do it at DRPC, you can go to the documentation. We trying to thoroughly document everything and to be really transparent about it. If you want to follow us on Twitter, you can scan this QR code. And that's it. Thank you for your time. Hope that was a little bit interesting.
Yes, thank you, Slava. And do we have questions? Any questions for Slava? Any questions? This is the quietest it's been. No questions. All right, going once. All right, thank you, Slava. We've got Nick up next. There we go, Nick from Assistanger. Take it away. Oh, we tried, man.
Hi, everyone. Hi, everyone. My name is Nick. I'm co-founder and CEO at Assister, and we're building human-driven data economy with small language models approach. We're a Cambridge-based startup. We start back in 2022 with thinking like, okay, what we can do by utilizing AI for Web3 space. And I had a background in AI space. I had a background as a head of ecosystem growth in Web3 protocols since 2017. And we found that there is a lot of inefficiency into how protocols and developer-facing organizations run in the processes of supporting developers, building relationship with them, supporting tech documentation. So we start with this AI agents automating DevRel support, which right now it's standalone business. We already have live integration with Solana, Optimism, with many other guys in this space. And we simply save them money with AI automation by automating documentation part, by automation support, and other things. But as soon as we start working on this, we start getting requests from big protocols like Solana, like, hey guys, that's amazing, but we still have too many requests that cannot be supported automatically by AI. And we start thinking like, okay, we can add ticket system. We can process this manually. Your DevRel team can process this request from your community manually if our AI agents cannot provide support. But then amount of tickets get like bigger, especially if the protocol grows in the price. And there is a question like how to incentivize community to provide support, peer-to-peer support to other people. That's where we start thinking like how to scale what we are building, how to make it more interesting, and how to put community in the loop. And we found that there is a big problem, and we experienced this by building this use case for DevRel, that there is this, we call it last mile challenge with data required for AI model accuracy. And you see these graphs is basically if we're taking a base model, they can be quite different, depends on amount of parameters, depends on the budget spent by the company, so the accuracy would be quite different. But as soon as we add into LLMs, RAG process, they became almost equally in terms of accuracy. And if that's true, the question is like, why should I spend hundreds of millions or billions on training large language models or keep using this like centralized LLMs if I can use open source model or any model, but then add additional knowledge that would be up to date and would be adding this additional accuracy and context for domain-specific purposes. And these big tech guys, which exist in the space, they actually end up with the same conclusions, because right now you probably heard about Reddit, Stack Overflow, with Quora deals with big tech guys. What they are doing, they need community-generated content, user-generated content, because it provides this last-mile accuracy, but they don't want to pay you, they don't want to pay us for using our content, our data, our data sets. And we believe that it should be fixed because current data market for AI is kind of broken because there is mistrustworthy data provenance mechanisms that can allow us to check, okay, was my data used at some AI model? Was my data used by some specific application? And big tech companies, they don't have any incentive to implement this mechanism because it means that they need to share profits with you. While if there is no such mechanism, no need to prove anything and no any instruments to fairly evaluate and reward data contributors. So to address these challenges, we develop our on-chain data provenance protocol that enabling incentive-driven network of small language model. Where DePIN here, it's basically we empowering people to contribute data to each small language model. This model can be stored on decentralized infrastructure, centralized on your personal network. And then we also tracking who, when, and how change or affect a data set which is behind the model. And in that way, each of us or any user can get fair rewards, especially if the model data set which this specific person was contribute to was actually queried. So there is a mechanism how to even check and fairly reward. Let's say there is 100% of data sets behind the model, and only 10% of this data is actively used by user, basically querying by users. In this way, we can define which data and who was behind the ambition of this data and reward these people most, while other people, other contributor would be rewarded less. We recently, like 2.5 months ago, we won Autonomous Agent Hackathon at East Denver with this solution. And let's go a little bit deeper into the roles and how everything works. So we have 4 roles at this moment of time. So you can join ecosystem as a small language model creator. Basically, you will define which domain you want to target, which small language model you want set up, and you would be organizing people around this model so they would be basically contributing data or acting as validators. Also, we have data contributors. It's people or experts in specific domain zones who have knowledge, experience, expertise. It can be statistic information, user research, like whatever else. And they contribute data to the models which they have expertise in. Then we have a role of data validators, which is highly important because otherwise we will end up with spam models where people would be just like running for this like bounty or reward system or tokens, and they would just spam and lower down the quality and accuracy of the model. So the role of validator is to validate the quality of the data based on different parameters. And then we have a mechanism. If something happens and we will discover that the data contributor and data validator, they validated wrong data, low quality data, we have a mechanism how to penalize these people. And they also need, there is a staking mechanism to secure the network and other things. And also end users, they're going to be using applications. Why it's important for them? Because in the future, or even now, we have three options. We have Google search or any search engine. We have LLMs, which are averagely good and averagely bad for any use case. And we're going to have small language approach. And I'm betting, and our team believes that in the second half of 2024, small language approach is going to be super popular and hyping because we're discovering that large language models with these averagely results for everything, that's not something that business and real users want to use and want to have. In terms of the user flow, basically, users right now can register at Assister, choose a role, set up and trace small language models based on the data sets, information that they have. Then they can choose different service providers. Right now, we are partnering with IO.net in terms of decentralized storage, zero gravity protocol, other service providers. You can choose basic models that you want to use as a basic infrastructure and also add some crypto payroll. We're going to add Monad support, Solana support, and also EVM chain soon. Then you can customize UI UX. Right now we support different conversational chatbots. Right now we support web widgets that can be inbuilt in any web service that your company or your team is using actively. And then you're listing it on small language model marketplace. We're going to launch it next week. Where anyone can find your model, can choose the models which they want to contribute in, or join as a validator. That's pretty it. Right now we are running several use cases. So DevRel use case, which I mentioned, is already live. It's already generating revenue. We have 20 live integration with different protocols, while we're also running proof of concept with crypto analytics teams, with M&A deal flow teams in London, and a couple other use cases. From token utility perspective, so we have tokens that can be used as a vesting and also on a staking. Staking will allow you to governance and affect different decisions in terms of each small language model, but also on a protocol on an infrastructure level as well. Also, we have data ownership register, which basically keep track records about who, when, and how submit some specific information to this small language model. And it's allow us not to put the whole model on chain because we don't think that it's reasonable at this point of time because it doesn't give any pluses or efficiency to the speed of interaction, speed of training, and all of this. And also, we expect to launch next quarter kind of small language model launchpad, which would be allowing people to tokenize small language models that they want to build. So if you have some knowledge or domain-specific background, and people know that you can build and feed this model with your data, and you can organize community of 10, 100 people, maybe 1,000 people around you, they can also stake additional our tokens and incentivize you to build this application, to build this use case faster, and support your community in that way. And of course, you're going to be sharing profits from this small language model with the community who support it. We see huge market opportunity. So Bloomberg estimates that Gen AI-powered application is going to be bigger market than App Store as it is right now. And there are some companies who are running some, at least targeting this space in different ways, like Sahara, MyShell, OAS, FetchAI, and so on. The difference that we're targeting, we try to tokenize not only the protocol level, but also each application, each model level, where community can contribute and get some incentives for contributing the data that wasn't discoverable before, and anytime before. And right now, anyone would be able to get exposure to this. So imagine you want to launch your product on B2C product on a China market. So you would get some small language models that train on B2C data by B2C experts with specific exposure on China market. And there would be such use cases, just like endless amount of use cases that could be done in this model by using our infrastructure, by using our approach. There are several companies, as I mentioned, who targeted this space. The difference between us and them, we have working infrastructure, we have already revenue, and we keep running this. So we want to get more exposure with more use cases. So that's my call to action to audience that is here. So first, we are hiring AI researcher to work on decentralized vector DB. So it's something, if it's something that is interesting to you, I would love to chat after this call. And also, we are welcome to join the ecosystem as a small language model creator, data contributor, and data validator. That's it. You can follow us. Thank you for your time.
Great. Thank you very much. Round of applause. Any questions? Yes, in the front row. I'm coming to you.
Hi, can you speak a little bit more about why you feel like small language models are going to be, why are you more bullish on SLMs versus just fine-tuned versions of LLMs? The entire reason we built LLMs is because narrow AI and smaller models were worse.
Yeah.
And,
so why I'm bullish about this? Because I used to be co-founder of AI startup. We were doing very practical business automation use cases for sales function, for design function, and DevRel function. So it's like 3 different business use cases that we were automating. And each of these use cases, if you just use an LLM, you would get like 50% quality of result, accuracy of result, up to 60, 70 with LLM. While if you set up in vector database, with the fine-tuning, it's not an efficient approach. So it's a fine-tuning, it's different stuff. And also it's a question does every team, every company has expertise and knowledge and willing to fine-tune its own model? In many cases, it's not a case. So we think that the way how we target small language model approach is the most cost-efficient. It's the most democratized option for wider audience. And it's also this community element. It gives opportunity to get data that you need for accuracy. Because otherwise, with fine-tuning, you can do it if you have a lot of data and you have a big organization. But if you have some small level organization and you don't have this, I don't know, thousands of people who can feed it, it would be not accurate.
Question here.
Hi, I have 2 questions. One is, how do you differentiate this versus Singularity Net? And second is the way.
Sorry, can you repeat the first one?
How do you differentiate Assister with Singularity.net? And the second question is, if one were to convince a traditional company, what does the tech stack look like? Like a rough tech stack, the way Fluence showed basic tech stack, how would it look like if someone were to use this in a traditional company?
So the first question was about Singularity. We know really well that team because we are also Outlier Venture alumni. So we know the space really well, and we chat in and we have advisory from them. They have different approach. They have different go-to-market strategies. So it's just a question who will end up on which sector of the market, on which domain of the market. So I think it's just healthy competition, and we will stick at some use cases that would be most popular for our users. That's why we want to onboard as much as possible different small model creators on a platform. We will define which use cases are most popular, and after that we will fuel more growth in that direction. So it's the first question. In terms of tech stack, right now we're using vector databases. We're also experimenting with small language models like LLM, with Mistral, with one more, Tiny, I forgot the name. And in terms of blockchain, on-chain stuff, we basically using Solana, and we're also going to use Monad. So we're going to be launching on Solana in Q3. In Q4, we're going to be using Monad as EVM hub for EVM users, for staking, for reward distribution, for storing data about the data provenance, and so on.
Great. All right. Well, thank you. On to our last round of applause, and we're moving to our last panel.
Thank you.
All righty. Panelists, get up. Come on down. Do we have panelists? Lucas, Shannon, Stefan, Vincent, let's get up there. There we go, I see Shannon walking up. Good, Lucas gets first prize. All right. There goes the line.
Thank you. Cool. Do I need it? No, right? Okay.
Great. All right, guys, the panel is about to start.
Okay,
last
panel's
panel,
about to start.
you guys can make it. Everyone quiet, quiet, quiet for the very last panel.
Thank you, Tom, for being a great MC. I see you like walking around trying to push people back towards
Ryan,
the stage.
it's hard.
We'll try to do our best to entice people to listen to us by making it super interesting. The topic of the panel is real promises of DePIN and AI. Robert talked earlier about kind of how DePIN is creating value, and he talked about like how different parties are trying to capture that value. Let's just use this panel to get super specific and discuss how we're creating value specifically for AI use cases, and maybe we can dive into the specifics a bit, right? There's whatever inference, there's the training, there's the data creation that feeds these models. I think there's lots of ways to basically add value to AI. And then I'd love to hear how you guys are thinking about capturing some of that value, or who you're enabling to capture value by using your protocols and the technologies that you're building. And then because it says real promises, let's talk about both kind of the potential, the promises, but then let's also spend some time thinking about how we might chart a path to get to some of the things that maybe we will ideate on, as opposed to being super specific. Let's start with, instead of kind of doing a round of introduction, let's just combine it with the first question, which is, how does the thing that you're working on create value in the context of AI, right? And use that to kind of talk about what you do, but try to be very specific in how it really creates value for AI. Cool. Go for it.
Hello. Hearing? Okay. So I'm Eleni, I'm Senior VP of Engineering at IONET. So we connect GPUs from data centers, crypto miners, consumer hardware, and offer a solution that's on demand to exactly distribute processing of AI workloads. So you can spin up a cluster and have different types of jobs of AI, then you can think about batch inference or distributed training and other aspects of it. And the idea is that there is a increasing demand for GPUs, and we have all these underutilized GPUs, like we want to be this connection and offer an easier barrier of entry for them. So we've been recently investing a lot on facilitating the use of the clusters and also considering the nature of the decentralized network, which has some challenges.
Cool. Okay, so what I'm hearing is basically helping GPU owners add their capacity, so we're augmenting the supply of hardware that can run AI workloads. Shannon, what does LivePeer do to create value in the context of AI?
Is this on? It's on. So I'm going to try and make this pithy. LivePeer is making it easy for developers who want to build generative media applications to access on-demand infrastructure for those AI inference jobs. So LivePeer is not in the business of training AI models. We're in the business of providing AI inference pipelines to developers. And what's novel about that developer gateway is that you can pay per use for your inference requirements. Right now, if you use centralized data servers, you have to pay for blocks of time, which is not efficient. So with LivePeer, the way our pipelines are set up for generative pipelines, and right now you can do text to image, text to video, image to video. You pay per inference task, so it's much more efficient.
And just help me understand what that looks like from a user perspective or from a developer perspective. They go to your website, or like, what does the interaction really look like?
Yeah, so you can, the docs right now are in alpha, so I mean, the backstory behind the thing I just said is that we've just added the supply-side capabilities to our network. So for the last 5 years, node operators on LivePeer's decentralized video infrastructure network have been doing transcoding jobs, so video transcoding. But in the last 3 months, we've upgraded the protocol to allow our node operators to send and receive and execute jobs for AI inference while they're still doing GPU transcoding. So what does that mean? So that took some time. We just finished that. We have alpha developer docs, and anyone can go to livepeer.org, go into the docs, and play around with different gateway tools right now. But we will be improving the developer experience around that to make it even better over the next few months. But we've already had demo applications built on the subnet within the community. You can see a showcase of those applications. I think most all of those have open source code as well.
Got it. Okay. So what I'm hearing to a degree is like you've almost like taken an existing infrastructure that was creating value in a video encoding environment, and you've just repurposed it to now also kind of take some of those AI workloads and
exactly. So the market dynamics and the market mechanics are identical for video transcoding as they are for generative media inference right now. So any developers that need transcoding on the network are also paying per minute transcoded or per job transcoded. So we just kind of like took that architecture. It's the same payment mechanics. So node operators receive payments in ETH from gateways requesting these jobs. So we've been having a lot of success over the last few years with transcoding because it is 10 times cheaper than any traditional Web 2 cloud service for doing transcoding. And when you're streaming at scale, if you're operating something like Twitch or TikTok, your infrastructure bill gets really high. So we've seen success with that, and we're excited to have a big impact in the market around generative AI.
Cool. Awesome. Thanks so much. Handing over to you. How does what you do kind of create more value for AI services, maybe also unique value, right? Like what are some things that you can only do with decentralized? What does decentralized bring to the table in the context of AI?
Yeah. Hello, everyone. My name is DePIN. I'm from Cyberfund. Cyberfund is a venture fund. We invest in cybernetic economy for more than 10 years already. And cybernetic economy is this idea of like the different processes in the economy are manual or analog. You need like bureaucracy, you need banks, you need traditional institutions, and we invest in everything that helps us go into more programmable economy, which is run by and powered by mechanism design, decentralization, cryptography, and artificial intelligence. And I think if you look from high level on the AI and Web3 and DePIN, there's obviously a lot of applications of like AI can be helpful to any industry, including Web3, including blockchains, including any other vertical in the world. But I think the most important things are where do existing Web3 concepts and technologies help to advance AI or help make AI more decentralized, how to help make sure that AI is not controlled by single entity, that like everything that we think, buy, or find online is not controlled by Meta or OpenAI. And I would roughly or generally put it into 3 buckets. So first part is cryptography. So we have a lot of cryptographic tools that help us ensure that data, models, agents, interaction between autonomous agents is kept private. The integrity is there, authenticity of data, provenance of data. So that's kind of application of cryptography to existing AI products. Second part is incentives. I think a lot of previous panels were about that. So we can use mechanism design, economic design, tokens, smart contracts to ensure that different actors that participate in creation of AI tools are rewarded, and you also fight fraud and kind of malicious actors. And then the third piece is governance. Governance is hard. It is maybe not as kind of big right now because we're still figuring out governance in Web3. But it's also important because, again, we have all these kind of large corporations that spend hundreds of billions of dollars on building AI, which is good. They're advancing the technology and the industry, but fair and equal access to the benefits of AI and also making sure that AI remains unbiased is very important, and that's where kind of decentralized infrastructure, both physical and software, can help and is helping, and that's I think unique. These three are unique values that Web3 industry can bring to AI.
Cool. Okay, so cryptography, incentives, and what's the last one?
Governance.
Governance, right? As like the unique kind of things that decentralizing AI and like these kind of workloads bring to the table. I think that's super interesting, of course, because of like provenance and where data is generated and are people participating, right? There's a number of lawsuits, I think, that are ongoing where people are saying the contribution to this training data wasn't accurately rewarded, etc. So I think that's like really interesting and teasing out like why do we need to decentralize AI, right? In addition to what we heard before, which is driving down cost and repurposing tools, making it easier for developers to kind of contribute to innovate. Cool. Over to you and kind of maybe talking about why we need to decentralize AI. We know that we have heard some of the benefits. What else does decentralized AI bring, and then how do you create value with what you're doing?
Yeah, so my name is Vincent. I'm the founder of Prime Intellect, and kind of like our focus in this context, like also building on what you already laid out, is really to aggregate all of the compute in the world, like even including from centralized providers, like not really making a distinction, and making basically orchestration easier for training, for inference, for other workloads, and really with a focus initially on decentralized training. So basically, if someone wants to have a bunch of GPUs to train on them or to inference on them, there's now like hundreds of providers, and it's difficult to orchestrate actually that workloads. And most AI developers don't know most of them because there's so many of them and are not integrated with them. So that's the core problem we realized talking to AI developers and AI researchers and startups is like all of them want and need access to cheap GPUs. Like it's kind of like the oxygen for them to breathe. And I think the core promise that crypto has in general is like it's really good at creating financial markets and creating efficient financial markets. And ultimately, I think compute will be the biggest market in the world. Like by far, I think might be the majority of GDP. It might be the majority of like financial assets. So I think crypto is pretty well positioned to basically drive down cost of capital to an extent, and the efficiency of like compute as an asset class as well. So I think that's like a good tailwind for bringing compute, but also even AI models and other like compute adjacent assets on chain and making them like tradable basically. And then concretely for like what we are building is and already like have out there is like really making it easy for people to use to compute from all the decentralized clouds, but also some of the centralized ones. And then not only train decentralized, but also basically figure out novel funding models for people to get compute to build AI models. So I spent the last few years in decentralized science, kind of like tokenizing IP, funding tens of millions of research on chain, and that worked. And ultimately, I think it's very similar for AI research, where there's like basically lack of business models actually for open source AI. Like basically, you could either go the Anthropic or OpenAI route, raise billions, or obviously go fully open source like Llama, where there's kind of like a lack of incentives. But I think there will be like a lot of like middle grounds. The best example might be something like Stable Diffusion, like obviously one of the leading like image AI models. And it's free available, but like if you want to use it as an enterprise, you have to pay them for all the cost that they had to train this model. And I think this model will become more popular, and I think could basically enable like collective funding of like open source AI models that actually get monetized and like get earn licensing revenues. Yeah, so that's maybe like the high level, but I think yeah, building on everything what everyone before said, I think there's like a lot of opportunities basically for the space.
Cool. I'd love to dig in on this financialization aspect, which is a really powerful tool that I think decentralized networks in general can use to bootstrap a bunch of GPUs and network into existence to attract developer attention, right? Like the incentives are really powerful, and you mentioned it as like one of the unique things that we can leverage in this space to grow. At the same time, there is also a risk in that it introduces a lot of noise to finding product market fit, right? Because you might have networks that optimize for growth and providers that optimize for mining incentives, as opposed to developing a product that finds product market fit and solves a real problem. So I'd be curious, like maybe starting backwards a little bit, like how you think about that, like how can we drive towards product market fit, something that AI, at least in the centralized context, has very powerfully demonstrated, right? With ChatGPT growing to 1 billion users like overnight. I don't know the exact numbers, but some super impressive growth. And now we have, in the decentralized space, we're leveraging incentives, we're growing GPU networks, we're able to attract developers, but we have yet to see this like aha moment, I think, of finding product market fit. So I'm curious, like how you think about, leveraging the potential of incentives, why not falling prey to the risk of diluting the signal to noise ratio when driving for product market fit?
Yeah, so like for us concretely, like when we observed the space and also followed like the Filecoins and the Cashs of the world, like in the first wave, like our key realization was that they basically were able to bootstrap incentives for the supply side and for bringing on compute, but usually had like huge friction for actually the demand side to use the now like much cheaper compute. So we kind of like inverted that and said, okay, like no one is using decentralized compute, let's face it, like literally no one. Like if you look at these networks, they have close to no usage right now. Like, and why? Like
Except live here.
Yeah, maybe, and I mean it in a grand scheme, right? It's like 100% of compute usage in the world, like how much percentage of that is decentralized networks? It's less than 1%. Like, and much more less than 1%. And I think the key there is like why? Like in a lot of cases, you need like a Cosmos wallet, a Solana wallet to use it. AI developers in general, like and startups we talk to, like they have huge overhead dealing with crypto. So they don't want to deal with crypto. And like that's what we basically did is like we integrated a bunch of these decentralized compute networks and completely abstracted away crypto. Like they don't need to touch crypto. Like they can pay whatever they want, like with Stripe. And that's what like when you talk to users, that's what they want. Like they want cheap compute and they want to integrate and orchestrate natively, and like so that's basically the first step we took. On like on the incentive side, we believe all of these networks will be great by basically having lower cost of capital, which is ultimately the key component to bootstrap the supply side. But you do need to bootstrap the demand side. But the demand side like doesn't need incentives; it just needs the cheapest GPUs. Like for example, but like if it can't use them, or if it's too hard to use them, or if they're unreliable, or if you promise an H100 and the H100 doesn't work, or the H100 doesn't even exist and it's a whatever, like V100. Like all of these things happen in these networks, and like we ran a bunch of experiments on a bunch of them, and like the reliability is not that great. Sometimes you don't even get what you're promised, etc., etc., etc. So we basically make those things easier to actually bootstrap demand, and ultimately, obviously, by also having the centralized providers, it's much easier because then you can tap into both sides. But I think to your question, I think we also need to, like it's a two-sided marketplace where like, yeah, I think the user experience is much more important than product market fit than kind of like these artificial incentives that promise like product market fit while it's actually just like incentives. And I think, yeah, basically the high level for me is like something like Filecoin I think works, but like the incentives ultimately are now much more like effective. Like initially they had to overcompensate with incentives, and I think now it's much more efficient. So I think with some of these earlier networks, you can see like they start quite aggressively with incentives, and then it becomes more efficient once there's kind of like efficient markets kicking in.
Yeah, got it. Aline, maybe to contrast that, right? Because you've very successfully shown again to build kind of supply side. There's a lot of interest in IONET, I think specifically, and they're kind of heralded as yet another example that has very successfully aggregated supply. Like, how do you, like, what does that make you think? Like, is that truly a problem? Like, how do you guys think about, you know, things like prime intellect, like solving a real problem there for you? Just
yes, as a network that we operate, sort of as a broker, like we need to increase like consumers and suppliers, and if only one side increase, then like you sort of need to optimize both sides. So definitely you don't want a high number of suppliers that are underutilized, and nor like users want GPU. So basically, like I would say, like the training model, distributed training model, like is more of a mid-long term, because I would say it's a harder task considering the decentralized network, and the inference it would be like a less harder task for the decentralized. So the way we see is like these models, like for inference, that you need to do inference at scale, at a global scale. Sometimes like overall like knowledge, like global knowledge, they will be like, they will create a steady flow on the network. Like they would be the first like less harder task like, to have this steady flow, and this is something that we are investing hardly. And for the training part of it is research and engineering at the same time. Because we can see like the communication, like when everyone is working in the office, like everyone can synchronize with everyone instantaneously. So it's like the distributed training requires that all the nodes needs to sync very frequently. So if they are very distant, like it's a harder task. And for inference, like it's more independent task that they can take, so the communication is lower. It's not, but it's possible that we improve the way of the communication of distributed training, but it's a working process. It's a heavy research taking place like at Meta, at universities, and also at IONET, because the same way like we thought that we could work only on the office, we couldn't work like in the decentralized manner. When the pandemic came, like we suddenly learned that, yes, we can communicate remotely. We don't sync the way we sync before, but create another protocol of communications. So in this distributed training, there are ways that, and the research are around how you change the communication protocol, the different ones, like gossip is one of them that we also have in Office too, the gossip protocol. So like how you change the different protocols. So there is, answering like there's space for distributed training, there's space for global scaling, and the global scaling would be the less harder task, and that's the one that will take the most share of our network in the short term.
Got it. So I'm hearing kind of like be realistic on the types of demands that you can actually solve, and then just go after those as opposed to solving it. Oh, go ahead if you.
Yeah, like the one thing I would add, which I think is like very true to your point, and like it's the one main thing like we also saw as a problem is basically like for context, like on these big training runs, right, by OpenAI and Anthropic, they have all of them centralized in one cluster. They synchronize every training step, like literally milliseconds or in seconds. So it really becomes impossible, like in a decentralized context. But what was interesting for us, and one of the also like inspirations to tackle decentralized training was actually DeepMind kind of like solving this recently in like December with like a project called like DLoco, like distributed low communication training, where they only synchronize every, for example, 500 steps, which might be only every few hours. And that's basically what we're replicating right now. So we're training, like we're basically open sourcing their research and scaling their research. And it's starting to work. Like obviously it does have downsides, but like if the GPUs are 3-4 times cheaper, and if you can basically aggregate the cheapest GPUs in the world, then you suddenly have such a cost advantage that ultimately it's okay if it's 20, 30%, whatever, like more inefficient to train decentralized, if it's 80% cheaper or something.
Yes, so there is
even research that shows that you can, even in a gel-distributed nodes, like by reviewing the way you communicate, the protocol of communication, like not that everyone syncs with everyone, but different nodes, and then they sync at other levels, they can be even like more efficient. So this is something that we have. So this would be like mid-long term, and we see that the inference will be as a less harder task would be, and beyond the geopolitical aspect, like having more supply joining this network and having some libraries on top of it that can streamline the process is something that needs to exist. Like we cannot have idle GPUs while we have a lot of AI demand. So I joined IONET like because I said this is something that needs to exist. I was before like 20 years working in software industry with distributed computing for 10 years with biggest APC cluster in Latin America, and then the 2 years at Amazon, but they are all centralized. So it's a hard task, but it's easier in this aspect that we're centralized. And for me, like, this decentralized is a real challenge. And I joined IONET not in spite of the challenge, but because of the challenge. So I think the problem needs to be solved, and I think we are well positioned to solve this problem. Like we are reaching 100 in the team, so we are taking this, grasping this very seriously to have and also be a place that research can take place and test these different algorithms on top of the network.
Yeah, what to be like maybe a little bit play the devil's advocate. It does sound to a degree a problem that is still looking for a solution, right? Where you have the supply and then you now have to figure out a way to affect the cost structure in a way that you can actually compete with something that's centralized. And once you do, then you're actually like in a mode where you can start to compete. I'm wondering, Shannon, like for you guys, because you kind of interjected earlier, except for LivePeer. So like, how do you guys? The other way, by the way, right? To go about this would be like, what's a big problem that a customer has? And like, how do we solve it? As opposed to like
LivePeer is very focused on a very specific use case, and that's video and media workflows. So we're not looking at the generic space of AI compute. Even when you look at inference, I think there's like an infinite number of inference tasks that need compute. We're really focused on understanding what are the use cases and really new internet and consumer applications that are being built with generative AI and what inference tasks are adding value around video workflows. So specifically, you can just start with creation, right? So that's where we've started. We've already added AI inference pipelines to our decentralized network for text to image, for image to video, as I mentioned. We support any Hugging Face diffusion models in order to do that. There's some work that our community is doing to make it really easy for anyone to bring their own model for those jobs, but we're also really rapidly building out pipelines for video upscaling, scene classification, like all of the really specific job types that make sense for video, because we don't want to be, everything for everyone, because it's really hard to find product market fit that way.
Cool. Let's switch. How much time do we have left? Can I get like 5 minutes? Okay, great. Then let's switch gears a little bit and talk a little bit about the governance thing, because I think one of the aspects that you outlined earlier is like the key differentiators that decentralization can bring here. I'm curious, like, what are what's your vision kind of for an AI service that is, governed in a decentralized manner, and like, how does that look different to, the corporate, whatever, dystopia that we're now collectively learning to fear, right? Like, maybe paint a bit of a picture on now, we talked about incentives. How does the governance and decentralizing those aspects, like, help us work towards a brighter AI future?
Yeah, so governance and coordination is kind of the final boss of everything in Web3. That's the hardest problem, and that's why it exists. Like, Bitcoin is trying to solve the problem of governance in monetary system. Ethereum is trying to solve governance problem in kind of compute verifiable and compute specifically for financial use cases. and none of those are, like, this job is not done, and it won't be done for maybe decades to come. And we're talking about AI because it is just one of those use cases that will probably be at least as important as money, but maybe even more, because in 5 years, in 10 years, we will use AI assistants to do everything, to organize conferences, to find
the whole
jobs.
panels will just be will all be AI agents.
Digital twins will be answering questions on the panels. So, and there's just the existing coordination system is not fit for digital future. We see that politicians deciding monetary policies in their interest or in interest of them being re-elected is not like working for many countries. At least, like I want like shield Bitcoin, but you know, and the same thing will happen and already happening in AI. So there's a few companies that spend a lot of money. AI is super capital intensive, and compute and model training are two kind of the most expensive parts of it. So those organizations who own compute, who train the models, they then will be able to monetize and kind of influence what these models are doing and why. And governance can be, like we can look at governance from two angles. First angle is automation of human governance. So maybe we can have a DAO or token voting to allocate training resources towards some model that will benefit, I don't know, healthcare research. And governance, second kind of angle to look at governance is self-governance. How do we make kind of automated systems using mechanism design, using on-chain autonomous agents that are able to make decisions more effectively, more efficiently than people do, because they think with the speed of light, because they have access to a lot of information, and because we kind of use these models of kind of game theoretically optimal design that we do in existing blockchain networks. And autonomous agents are one approach of trying to solve this.
Yeah, I think like there's a lot of good points there. Like where, like I was also almost like drawn into crypto by governance, like by the first DAO, which got me excited and like getting into this space for that. But like ultimately, I think there's different layers to it, and I think like one relevant one is seeing that still like obviously the majority of the world is not on crypto rails yet, right? Like I think that it's kind of like, especially for AI, I think there's like a lot of ideas Sam Altman put out there. Like even though one might disagree on a lot of things with him, I think like he's also right on a lot of things where like to an extent we need universal basic compute and incomes, etc. And like we need a way for basically every human in the world to help govern like AGI basically, or like more powerful AI systems. But I think connected actually on the crypto part, and even to be honest, like on like political level, on like protocol level, on an AI level, I think how the future might play out, and I think it's to an extent even how politics works, is like that people reveal their preferences and like refine them over time. Like I don't want to vote in a DAO. Like I'm totally honest, like it's too much time. Like I don't want to vote on every decision by a government or by like an AI organization. I just want to like refine my preferences over time. It's like, what do you care about? Like what should the government, what should your company, what should your protocols or whatever do for you based on your preferences, right? Like what do you care about and what do you want to an extent optimize? And I think like that's the future, like where there's a risk if there's like one centrally governed AGI that is like governed by like the US government or the CCP or whatever with their preferences, which are different than your and my preferences and different than anyone else's preferences, from political biases to a bunch of other things. And so I think like we need a future where like everyone can basically program their almost like preferences and thus govern AI, govern everything else, like including crypto. And I don't think like the current crypto governance like really works that well, or like has that active participation. And I think that's like one of the also things which I think crypto could deliver today, like have AI agents that where you ask answer a few questions and then it just votes on your behalf based on your preferences. And I think like with delegation and whatever, and I think that's an interesting like prototype for like scaling this to a bunch of other things, including AI itself.
I think what's also important here is that the presence of alternative ways of governance, right, as opposed to centralization, doesn't necessarily mean that they materialize for all sorts of reasons, right? One is like absenteeism, that people just don't vote even if they have the opportunity to. So I think it's great to kind of like have that as a chance, but we need to realize that it does take a lot of work, and we will be competing with a very powerful centralized system. So I think there's a lot of promise for decentralization to do good, but it's not at all a given, right? And I think that's go ahead.
Yeah, and a lot of AI, and not just AI, but a lot of projects in crypto, we can think of it as a sandbox, really. Like a lot of things exist just for speculation. And like there's maybe a good idea, good token, it like listed on Binance, everybody buys it, and there's no product. That's fine, because this is the way how we can test the systems before going into production. Because previously, like think of large corporation, or think of like a nation state or country. If you want to change a governance system, it usually takes decades. And you're lucky if you like don't end up in war or revolution and a lot of people dying. So the fact that we have this on-chain sandbox system with not a lot of people, but a lot of actual value, so a lot of incentive to try and make it right, is good, because we can do many experiments. Like I can launch a DAO that consists of autonomous agents that are trying to maximize my own kind of benefit, try to benefit me. And in 1 week, I can try one approach to governance, maybe like a direct democracy. And second week, I try a delegation. And third week, I try maybe like a more autocratic approach. And at the end of the month, I get actual empirical results, what works best. So because it's programmable, we can apply scientific method to governance, to coordination globally, and not wait hundreds of years and not like end up in like bad scenarios like revolutions.
The one thing I would add is like, which I think is one of the most fascinating concepts in this direction, is stuff like future key in this direction, where you could basically review the preference functions, then run prediction markets, and then basically have almost like a market and your like preferences like govern everything. Like, and I think that's like worth trying also in the crypto context and then scaling it to other spaces.
Yeah, I do think there's a lot of, that's cool, right? Like we can experiment with different governance mechanisms without the risk of killing a lot of people. And I think that's really useful. But I also do think, and I don't have a great answer right now, but like my intuition is that governance is not a problem that can be that has an optimal solution, right? There's like a bunch of, probably different equilibria that are optimal for different. Anyways, a topic for another debate. I think I'll close now. And on the topic of governance, everyone who can vote should vote in the real elections, because they're happening right now. Cool. Cheers. Thanks, everyone.
Great. Thank you guys for a great panel. Round of applause, please. And this was our last panel. So the bar is open. This is the part where you're actually supposed to talk. And that is coming, that's right now. I just want to thank everyone for attending. I want to give thanks again to our sponsors, 1KX, Impossible Cloud, and DRPC. A round of applause for them, please. Thank you. And then if you enjoyed this, we are doing this all over again next Friday, just literally a week from now in Austin. So book your ticket, get on a plane, get to Austin. We're doing it right there on the 31st. And then again, Brussels, July 10th, if you are sticking around Europe and are going to meet us there. Belgrade is June 7th. So a lot of events coming up. And don't forget the DePIN podcast. Some of these panelists have been on it, and a lot more. All this content will be different at every one of these events. So thank you again. I hope you had a good day. Enjoy the drinks. Onward.